why don't we have why don't we hear from, I can see,
Hello.
yes, yes.
I guess I see the Councillor Ashipo Moi on the call.
Oh, great. Okay, thank you. Uh, we have our another student branch counselor. He's from Moi University. This is from Kenya. We have Mr. Severinus Kifalu. Karibu sana, Mr. Kifalu.
Thank you very much. Am I audible everywhere?
You are indeed.
Okay. Good morning, everybody. Good morning, community. Good morning, all the international. Good morning, all the locals.
Morning.
My name is Severinus Kifalu. I'm also the chair of the department in electrical and communication engineering. And at the same time, I'm the branch counselor for IEEE in Moi University, the students branch. I want to thank everybody for being part of this conversation today. Though it happens I'm on the highway, but I will try to log in whenever chance allows. And in between meetings, I'll be logging in to see how things are going. First, I would like to air my sincere gratitude to the IEEE for the support that they have rendered to our students outside their regular curriculum activities. It has gone a long way to help these students, and I've seen some of them go far, even like they are becoming professionals, taking a shorter time than some of us during our days. And this is very good. I like the developments that IEEE is bringing to our students. I urge many students, let's say, if possible, even all students of engineering, to be members of IEEE, and this will enhance our knowledge and their knowledge, and also it will give benefit to millions of these students. I mean, it will benefit them because of their connection with the millions of peers in the world around in this profession. And I want to say that the key to this prosperity in our country is networking. And this is very good that IEEE is enabling this networking in the country and in the world. So I look forward to a great event today. Just because I'm on the highway, there isn't much I can say, except, as you can see, going back to the road, but I'll be together with you throughout the day. So I thank you very much. I thank you very much, and I wish you a great day today in the deliberations. Thank you. Over to you, Wangatune Mwaura.
Thank you so much. A round of virtual applause to him.
Okay.
Thank you so much, Mr. Kifalu. For sure,
Welcome.
for sure, the key is networking, and
Yes.
we need to interact. We need to network. So, my friends, my participants, kindly just share your network, share your LinkedIn profile. Let's have as much interactive as possible. Thank you so much. I don't know
Okay.
if there's any other student branch counselor who is available.
Okay.
Okay, so maybe we can continue with our conversations.
Okay, Tune.
Yes.
Hi.
Hi.
Awesome. I'm just listening in. I'm not sure if you've heard about from Strathmore University.
Strathmore University.
Yes.
Yes, of course we have.
No, I mean
So,
the counselor.
yes, we have.
Okay.
Okay, but let
The
me.
counselor from Strathmore University has not yet checked in with us. I think that's what he's asking.
Oh,
He's not
okay.
given his address.
Okay. Okay, thank you for that.
All right. Sorry, can I go?
Maybe I can assist a little here because I see Professor Engineer Nzomo, the counselor from Kenyatta University. Maybe we would give him the opportunity.
Yes, please. Karibu sana Engineer Nzomo.
Thank you very much. You are not able to see me. Nobody can see me. Can you?
And
No,
yeah,
your
not
camera
no.
is not visible.
Computer, but I can continue talking while I'm trying to get in. First of all, as a past chair of the Kenya section of IEEE, I'm very impressed with the progress made by the institution, by IEEE throughout the world, and for the quick uptake by engineering and technology students in Kenya, particularly the 13 to 15 universities and schools of engineering and faculties that offer the same. As the patron of Kenyatta University IEEE Students Branch, I'm very impressed with the continued uptake, as well as the sections, affinity groups that have been formed, including the CAS, Women in Engineering, Photonics, name it. I am aware that there are several other universities that have formed student branches. We are in constant discussions.
International Institute of Electrical Electronics Engineering Association. Institute of Electrical Electronics Engineers Association.
What do we agree? Do I continue talking?
Yes, please.
IEEE has gone beyond just electrical and electronics. It focuses on every profession that is involved in technology advancement for benefit of humanity. And engineering takes the lead in that area because our role as engineers is to ensure that life for the society and human beings is made more comfortable, and that is our calling. With respect to today's the theme of this particular conference summit for students is to encourage you. I'm now missing everybody. Can you see me? Is to encourage you to note that Kenya in particular, the foundation of the pillars. Have I been lost?
We can still hear you, Engineer.
Try and look for the camera. I'll use the other camera. The other laptop is on another conference. Later on, I will log with my normal computer. This one I'm using is different. I'm on 3 activities at the moment. I've just taken a break to talk to you and then go back there. I'm discussing biomedical engineering. What is important for engineering students to focus is that engineering forms the foundation, particularly for Kenya, upon which the other 3 pillars will be built. For Vision 2030 in Kenya, we have the economic pillar, the political pillar, and the social pillar, and all are standing on the foundation pillar. And that is where infrastructure and engineering comes in. Science, technology, and innovation comes in, and all the jobs that you people will perform are there. For the entire African continent, Agenda 2063 is again built on that. And needless to say, the Sustainable Development Goals for the whole world are built on that. So mine is to encourage you, remain focused, network with other students in other parts of the world, and build a bigger network so that trust among professionals is enhanced. And I think both my students and students from other universities, because I am the secretary of the Kenya Engineering Dean's Council. I know what they think of doing, and I'm very, very happy and encouraged by yourselves. And I thank you.
Thank you so much, Engineer. Thank you so much, Engineer Martin Zomo. I have to say, I have really gotten to understand that the role as engineers is to ensure that the life of societies is made more comfortable by creating a sustainable future and transformative innovation.
Okay.
Thank you.
Thank you so much.
We'll log again later.
Oh, okay. Karibu sana, asante.
It's surprise for it.
Okay, now we from Technical University of Kenya is Dr. Ahuna here.
Okay, she's not yet in. She'll be joining by exactly 10.
Okay. From Jomo Kenyatta University of Agriculture is Professor Kamau here.
Yeah, he was a bit held up today. Yeah.
That doctor was right.
Kindly let's unmute. Kindly let's mute so that I can easily hear.
Maybe I'm gonna hear for a small meeting the inside need
If you'll allow me to intrude again, sorry. Could the person who has got host privileges take that responsibility to mute
For him
those
to
who
tell me,
are talking out of turn?
Yeah, but anyone on layer
That's
as
okay,
us say what
and
which means always in an
kindly
Africa,
help
Kenya
us
has
hear.
the big one. Ka space ka trees na buy ka chance the oji awo potassium.
They already knew how the wound goes. My pan has him to work. I'm a one only can up that big. I him the nature yesterday. Oh, we are not woman. I say, Mbira nature. Say, nice. In any land, I will put an hour. We have got our now.
Only one.
Cause zero him the woman is yoga contaminating my blood.
One girl no ga banya banya na bloodstream no all say no young. Yeah, mutku. Ozo.
They take group economy.
Yeah, is the student branch counselor from Jomo Kenyatta University here? What about from Strathmore University? Is the student branch counselor from Strathmore University here? Okay, all right. So we are going to wait for them just a few more minutes as they arrive. Maybe we can, yes?
Sorry, I muted. I had to force mute everyone. because of the audio from one of the international guests. So if you would like to speak, just kindly raise your hand. I will unmute you and you will see that I have sent a request for you to unmute. So yes. So Mr. Stephen Gitahi, I've also sent a request for you to unmute. Can you see that? Okay.
Yes. Can you hear me now?
Yeah, we can hear you. Sorry about that. I had to
No,
force
it's
mute
actually okay.
everyone. Yeah.
It's actually okay. It's a good management plan there. So I'm glad to be part of this conversation today. I hope you can hear me clearly.
Yes.
Yes, I'm glad to be part of this. I'm from Strathmore University. I know you're aware that I have a branch here. They have been trying to set it up, run a few activities for I think the last 3 years now. And I think things are running well. And I'm expecting more activities from them and from us in general over this year and next year. So I've seen part of their yearly plan, and I think we should expect good things from this. I'm also happy to generally comment on IEEE in Kenya and the activities that are running and the impact that has had on students and also the community at large. And I think this summit is also an example of such. And I think just to reiterate that I'm happy to be here, and I'm glad to share this platform with the participants and also the other hosts that are here. All right, thank you. Feel free to anything else.
Thank you so much, Mr. Steven.
Thank you.
Situna, maybe we have a question for Mr. Stephen.
Yes.
As a co-chairs, we all came together from different universities so that we could organize this summit. So maybe we would like to forge a connection with Strathmore University now that they've started, and they started Faculty of Engineering. So we would like, even as you people are growing your student branch, I would really love to have more events with you people and with your student branch so that you can all grow. And now you're the new, you're the youngest now in the community. So would not like to leave you behind, but would like to all of us grow together and just we all become strong rather than we just leave one part. Yeah.
Great, Fiona.
So maybe if we could,
Okay.
yeah.
I can see the student branch councillor for Technical University of Kenya is in. Dr. Mary.
Karibu sana Dr. Mary Ahuna. Karibu sana Dr. Mary Ahuna.
Dr. Mary, can you unmute? I sent you a request to unmute. Can you see the request? I've sent you a request to unmute. Dr. Mary? Dr. Mary, just look, I've sent you a request to unmute. Yeah.
Okay, you can hear me? Someone can hear me?
Yes, great, perfect.
Okay. So
It's okay.
sorry for that hitch. I was
It's
trying
okay.
to unmute myself, but I was being told that I can't unmute. And thank you so much for taking me through. So I'm so excited today. It is a wonderful day. It's a day that we were really looking forward to. So I'm sure my name's already there. I'm Dr. Mary Ahuna from the Technical University of Kenya. I'll just go ahead with my short remarks. Honorable rectors of the co-organizing universities and honorable distinguished speakers and guests, all conference participants, ladies and gentlemen, on behalf of the Technical University of Kenya, it is my great pleasure and a privilege to welcome you to the first IEEE Kenya Engineering and Technology Summit. That is Engineering for Sustainable Future and Informative Innovation. So before giving the floor to the keynote speakers and the other speakers and back to the organizers, I will take this opportunity to make some general remarks and touch briefly on the IEEE. It is the first time the IEEE Kenya Engineering and Technology Summit is organized under technical support of IEEE Kenya section student branches. IEEE is a leading authority on areas ranging from aerospace systems, computers, telecommunications, to biomedical engineering, electrical power, and consumer electronics. I highly appreciate the dedicated work of the organizing committee, consisting of students and staff from all co-organizing universities. All work together and extremely hard for the same goal to prepare an outstanding summit. As a result, we have prepared keynote speakers, tutorials, panel discussions, technical sessions, that is workshops, to discuss the challenges, opportunities, and problems application of technology in various fields, including engineering for this year. So tender remarks to our dear volunteer students from various universities who are doing impressive work with a sense of responsibility and commitment Please, you can apply to them to have a question, or if you have a question or need, they will always be there to support you. The objective of the two-day summit is to learn and share knowledge among all and those who have rich experience and expertise in relevant areas of engineering, science, and technology. The IEEE Kenya Engineering and Technology Summit is a forum to bring together business people, researchers, scientists, software architects, and industry professionals to discuss innovative ideas and diverse topics on the next generation of information and application. Technology changes us. We live in the world where physical world exists in parallel with cyberspace and digital representations of ourselves. Today we have more virtual friends than real friends, forming together large online communities. We live in the world where data is the order of the day. In our world, it is easier to get free Wi-Fi than free water. Today, we don't use technology, but we live in technology. Internet is no longer a global network we connect to, but rather it is the interconnected world we live in. For our generation, the easiest and fastest way to change the world is to build a new technology. In concluding, I take this opportunity to welcome each one of you and express our gratitude in your agreeing to participate in this first IEEE Kenya Engineering Technology Summit. I am particularly grateful to our international and local guests who have managed to join us, to join with us even. We hope you will be able to join us next year, because this is not the first time, it's not the last time, sorry, it's the first time, but it's not the last time we are organizing such. So we're hoping that you'll join us again next year for KETS 2022, venue of which you will be communicated to later. Enjoy your participation in the KETS 2021 and memorable time. Thank you and have a wonderful conference day. Thank you so much. Have a great day. Thank you.
Thank you so much, Dr. Ahuna. Such great words. We are really happy to and excited to start this summit. Asante sana. All right. Wow. I am still mesmerized by the words that she has said. So we will get into our last remark from our student branch counselor. That is from Jomo Kenyatta University. We have Professor Kamau. Professor Kamau, are you here with us? All right. I can see participants sending in their LinkedIn accounts, their LinkedIn profiles. That's great. That's wonderful. I can see a comment from Caroline. She's saying that she's happy to be here. And yeah, she's just happy to be here. That's great, Caroline. Okay. I don't know. Fiona, do we continue with the
Yes, let's just head to the next section. When he comes back, we'll be able to introduce him.
All right. Oh, I have just gotten confirmation that the Jomo Kenyatta University of Agriculture and Technology, Professor Kamau, will not be available. So he has sent his remarks. He has said that this summit will be an exceptional summit, and he's sorry for not being there. Okay, now we'll get into the next session, We have great speeches and great conversations lined up for us. I am super excited to introduce to you our first keynote speaker of the day. That is Professor Christopher Minor. He's the Dean, School of Engineering and Technology, Director, Technical Vocation Education and Training at Murang'a University. He will talk about pre-college exposure of engineering at high school students using robots. So a round of applause for him, a round of virtual applause for him as we welcome Professor. Karibu sana Professor. Professor, can you hear me? Professor Christopher Maina. Karibu sana.
Auntie.
Yes, welcome, welcome.
Sorry, I've walked out a bit, but I was following up. Good morning, our MC for today, the chair of the IEEE student branches, distinguished researchers, engineers, colleagues. I've seen many of them around, fellow students, and both local and international participants. I would like to say welcome to Kenya for the international participants, and also welcome to my presentation for all of us as we share what our experiences are in engineering. So my talk, I hope you called me so that I can share the talk. The talk is on pre-college exposure, course to engineering using STEM. Now, just to give us a brief of what we'll go through, we'll have an introduction, then I'll talk about the engineer, who is the Industry 4.0 revolutionist, talk about green energy, Arduino, 3D printing, robotics, and then our experience in Murang'a University of Technology. As an introduction, we are all aware, or should be aware, we are now in the fourth industrial revolution, which is the ongoing automation of traditional manufacturing and industrial practices using modern smart technology. In other words, we are moving to large-scale machine-to-machine communication and the Internet of Things, which is being integrated in all our processes to increase automation, improve communication, self-monitoring, production of smart machines that can analyze, diagnose issues without the need of human intervention. And since we are going there, it is important for us to start early to prepare our younger students who are in high school so that they can appreciate what engineering is all about. So we start the pre-college exposure course. It was motivated mainly by low uptake of engineering and technology related programs, especially in Murang'a County, but we are aware that this is a countrywide thing. There is also low uptake of physics as a subject, which is a prerequisite for engineering and related disciplines, as well as lowly motivated physics teachers. There's a survey we did, and we noticed physics teachers are not the most happy ones we find in high school. And we thought this program can also do that. And a couple of researchers, and this you can easily check throughout the net, have indicated that there's a great impact of educational robots to the uptake and appreciation of STEM subjects. So all this motivated us to do a grant application to the Royal Academy of Engineering, which we successfully got on 30th June 2020. Our key partner is a private company called iSchool Consultants, who also deal with STEM robots. Our initial target was 27 schools in Kangema sub-county. So what did we do? The MUT pre-college course was designed to introduce the high school students to the broad spectrum of engineering and technology, the framework of Industrial 4 Revolution. So since we know the Industrial 4 Revolution is about automation and is about having a 21st century engineer with skills in clean energy, machine-to-machine learning, and advanced manufacturing, amongst others, then the course was technically tailored in the same. We had a general introduction of who an engineer is, and then this was followed by the basics of renewable energy, then Arduino programming, the STEM robotics, 3D drawing and printing, and finally there was a lot of play and fun activities. So the course in brief entailed the following. First, once we receive the students, we take them through to who the engineer is as the key Industrial 4.0 driver. And we take them through several scenarios for them to imagine a world without engineers. What will it be? No bridges, no cars, and such like things. And this they are able to appreciate because we try to make the slides and presentations as fun and easy to understand. And then we take them through what engineering as a career entails. The brief of it is that there's a lot of design, development, installation, operation, and testing of equipments and systems, building and testing prototypes, conducting research with scientists and engineers, writing specifications and technical reports, developing and controlling schedules and budgets. And once they appreciate that, we also take them through the basic essential skills they need to acquire. Some of them usually don't know that they require, for example, core subjects like mathematics, physics, English or Swahili, and chemistry as the core subjects. They need to know how to read and write blueprints, maps, schematics, good attention to accuracy and details, use of computer-aided design tools, and so on. So this is all done to help them appreciate then the entirety of the engineering course. Then another important thing that we bring to their attention is that technically we have two viable routes in education, engineering, and technology today in the country at degree level. So we have the Bachelor of Science, which we all know in engineering, which takes 5 years, and the main product is an engineer. And this is a regulated program under the EBK Act 2011. Then we have also the Bachelor of Technology in Engineering Technology, which is a 4-year program. And the main product here is engineering technologists. And the established ratios is that for every engineer, there should be about 2 or 3 engineering technologists to help him interpret the designs. This second group is regulated under the KETRB Act of 2016. So once they appreciate that, again, we take them through what is called the Kenya National Qualifications Framework pathways. And these are important because gone are the days one must get an A to do engineering. There are paths well established for us to grow from a level all the way to a PhD level. And those are established paths that are enshrined in an Act of Parliament, the Kenya National Qualifications Authority Act. And this allows you to progress from artisan to craft to diploma to bachelor's to master's to PhD. In Moranga, for example, if you come with a certificate course, you can join diploma and move all the way to a PhD in electrical engineering because the pathways are there. So that is very important, and this opens up their minds and helps them appreciate the education system we have. And once we are through with the introductory course, we now take them through the various aspects that the 21st century engineer should be aware of. We are now moving into green energy, moving into low carbon emissions. So what a time to introduce them to one of the systems, the solar photovoltaic systems. And here we take them through the basics of solar PV systems, from the features, the components, the systems, and solar energy in general. And there they are able to appreciate how solar energy is generated, how it is converted from photons to DC current, and how it is related to the weather in terms of if there is low irradiance, there is low output, high irradiance, high output. And all those aspects, they do them hands-on. So they are able to draw these graphs, they are able to measure this and appreciate. Then we also take them through the fact that models can be coupled together in series, in parallel, to form even huge systems. And we give them the example. I believe it's the largest in East Africa, Garissa Solar Power Station, which has a capacity of 54 megawatts, and the panels are on 84 acres of land. So, and they are able to appreciate that because now they can touch the panel and interact with it. Then we take them through some tools for measuring. Once they appreciate that, we now go to Arduino, which many of the university students are aware, as an introduction to automation and for Industrial 4.0. Arduino generally is a small chip controller, and the name Arduino encompasses both the hardware and software, and it can be able to process inputs and then use programmed code to produce an output. So generally for the high school students, we introduce them to the Arduino Uno, Arduino Mega, and Arduino Nano. Why Arduino? One is because it's the Arduino community is huge, and the main instruction materials available for free. The Arduino microcontroller is cheap, hence schools, teachers, individual students can buy for school or personal use. Arduino programming environment, the IDE is free and comes with pre-installed examples to jumpstart curiosity. Physics teachers can teach students about different applications of Internet of Things by building real-world smart devices. And finally, students can explore fundamentals of Internet of Things, such as sensors, automation, collection analysis, graphing, cloud storage, remote control, which are foundations for Industrial 4.0. Once they appreciate that, we also take them through 3D printing, and we both show them in reality, but also take them through the basics of it, which is an additive process where, just like the way we apply spread on bread, the same way we use the same technique to place layers of material to build up a 3D part. And we take them through the entire process, and they finally do it for themselves, from creating the 3D CAD model to converting it to STL format, from slicing into the thin layers to constructing the model, and finally cleaning up and finishing the model. And again, the aim of this is to make sure that the high school can access this at their own, at very cheap costs. So we use SketchUp. SketchUp is simple to invent in SolidWorks, but it's much easier to use and is free of charge. Hence, any school or student can use. So, and then this is a general setup of the 3D printer that we introduced them to. We have two types of 3D printers in Murang'a University. We have a more complex one and this simpler one. So this is the one we use for—
Excuse me, Professor?
Yes, yes.
Kindly share again your content. Some of us cannot see. It disappeared at some point. Just share it again.
I can do that.
Okay, thank you.
Can it now be seen?
Yes, thank you.
Yeah, you're able to see?
Yes, yes.
Okay. I don't know where you lost it. Was it here or before?
Now it's okay. Now it's okay. You can continue.
So, but the audio is clear, I hope.
Yes, I very clear.
Okay. So I mentioned Arduino. Why we go for Arduino? It's open source, and it's easy to use. The community is large. The microcontrollers are cheap. I think Arduino Uno, between 1,000 and 1,200, you get an Arduino Uno with some connectors to it. So teachers, schools, individual students can be able to purchase. The programming environment is free and comes with pre-installed examples. And consequently, both teachers and students can use very easily to build up systems and help the students especially appreciate such things as sensors, automation, collection, analysis, cloud storage, remote control, which are foundations of Industry 4.0. Then I went to 3D printing, and here we introduced the students to the basics of 3D printing, how layers are added to build up a 3D part. We take them through the entire process. We help them and give them assignments to create a 3D CAD model, convert it to STL format, slice it, do the actual printing, and then clean and finish the product. Then use, for purposes of drawing, we use SketchUp. Again, the aim of this program is to make it as easy as possible to mount anywhere. So similar to Invent and SolidWorks, SketchUp is easy to use and is free of charge. And then this is a general setup for the 3D printer. I mentioned we have two types. So this is a fused deposition modeling. So once the students appreciate this, we now introduce them to robotics. So all this is done parallel in groups of 10, so that we have personal contact with each of the students as they go through. So introduce them to robotics as a tool for pre-college exposure to engineering and technology. So first we gave them the definition of the robot, the mechanical device capable of performing a variety of tasks and performing tasks either on command or programmed in advance. So these are just two of the other robots that we are introducing to them. Some of the parts we are printing for ourselves so that to reduce costs. So once they appreciate that, we take them through the general parts of the robots, the effectors to simulate the arms, hands, and so on, the sensors to simulate the sensors the senses that detect objects, the computer or microcontroller which simulates the brain of the robot. In this case, we are using Arduino. Then we have equipment, the screwdrivers and such to help us assemble the robot. And finally, we have the power source where we use batteries or solar cells. And specifically, we are using lithium-ion batteries, and some of them recycled. So, which helps also in aspects of improving our environment. So the benefits of education robots, why are they beneficial? A lot of research has been done and indicates that education robots can improve on creativity and imagination. They are shown to improve teamwork. They are shown that we can learn, the students can learn from mistakes because there is a lot of trial and error before the robot behaves the way you want it to behave. It improves self-esteem. It also, there's a lot of critical thinking as you think of which sensor should go on and off so that it moves in what direction. There's a proactive spirit as they compete to make the robot work. Adapting to the future, because that's where we are moving over to smart systems. Then self-assessment, motivation for learning, and developing new ways of communicating. So what are the challenges? Because it's not the first time robots have been introduced to the education system in Kenya. One, the three main challenges we established is time issues, skill issues, and cost issues. And they are ordered in way of complexity. So in terms of time use, we noticed that where robots have been applied, they use they integrate robots to the curriculum, so making it part of the teaching aid. So you don't need a new course on robotics. Excuse me. And then number two, we have the skill issue. Most of the education robots coming from abroad are a bit complex to use. However, when we did the training for teachers and students, it was shown that a bit of exposure improved dramatically on how both the students and teachers can use these education robots. And then the crucial one was the cost issue. The first time I heard of education robots, they were costing for over $1 million. Currently today, there are some costing over 75,000. However, we discovered if we design and print our own robot parts within and use open source programs such as Arduino, the cost reduces dramatically. The cost reduces dramatically. So that's how we have solved that. And what we gain through the pre-credit course, we noticed that the students have a fuller, lasting grasp on science, technology, engineering, and mathematical concepts. They had the ability to think critically while solving the problems laid before them. There was resilience, there was collaboration of skills through distributed tasks, and there was the ability to communicate clearly in speech, writing, and drawing. So now I take you through what was our experience as we now wind up the talk. Number one, why do I believe our MUT pre-college course is unique? Number one is because at the onset, we give a general introduction to the students, what engineering entails, who can do engineering, and the career pathways as established under the K&Q framework. Number two, introduce them to renewable energy, specifically the solar photovoltaic system in easy to understand notes and experiments. Then we introduce them to 3D building blocks of robots, Arduino programming, sensors, motors, 3D drawing, and 3D print. Everything we do has hands-on experience on each of the components for the building process, integrating each lesson with topics in mathematics, physics, chemistry, geography, etc. And then finally, we use a locally designed 3D printer based on Arduino Mega to print the robot parts, leading to cost reduction. And then, of course, there's lots of fun and play activities as we do all these things. So how did we start? Number one, we applied and won a grant under the Royal Academy of Engineering. We partnered with High School Climate. The other co-sponsors are Engineering X and Lloyd's Registered Foundation. We did training of student volunteers and staff in MUT on how to program with Arduino, how to use the 3D printer, how to use SketchUp. Once we did that, we now printed our own robotic parts. This is printing in progress for the base of the robot arm. And so we were satisfied with the printing. We now assembled the robot arm and trained it to pick an object from one point and take it to another. And once we were satisfied that we can actually design a complete robot arm and successfully program it to do certain activities, we organized for stakeholders engagement. We involved the Ministry of Education, Teacher Service Commission, physics teachers, MUT staff, MUT student volunteers, and we carried out a successful stakeholder engagement. And our target group, as I mentioned earlier, were 27 schools in Kagema sub-county. So once we got a go-ahead from the Ministry of Education, we planned for the classes for weekends. You know, high school, you cannot engage in activities with high school students over the weekdays. So we booked them for 3 consecutive Saturdays. So the first day, we did the introduction class. And then after that, we did now go through several sessions. So these are sessions on solar PV, where the students are able to measure certain outputs, plot graphs, and take up various readings. Then there's robotics introduction, what are the parts of the robot, and so on. Then there was a training section on 3D drawing, where the students were able to draw parts of various complexity. And next we have students programming. They are doing to handle some tasks. Then next we took them through 3D drawing to 3D printing, where they are able to draw and then print the part that they drew. So once we did that, at the end of the course, we were able to establish the best performing students. We gave them some presents, and then the teachers were awarded certificates of participation for having participated in the course, because while we were going through the course, they were also engaged in listening and understanding the various aspects of the course. And then at the end of it all, we gave certificates to all the students who participated in the event. And this was day 3, and this was cohort 1 of 9. So we finished with one cohort of 30 students. We have 8 to go in the course of the year and next year. So at the end of it all, we hope to have exposed 270 students this pre-college exposure course. And on the side is one of the robots that we are using to train them. So that's my brief encounter with a pre-college exposure course to engineering and technology using STEM robots. Back to you, Gatune.
Thank you so much, Professor, for those impactful insights. Personally, I must say that I have learned the importance or the beauty of just imagining without engineers. We wouldn't have cars, we wouldn't have internet, we wouldn't even be able to communicate like this. For sure, exposing the high school students about engineering and the importance of maths, physics is really important, and also to let me switch my video on. Oh, okay. Yeah. Hello. And also just to show them the importance of our education structure. I have also learned the benefits of educational robots, about creativity, about teamwork, about self-esteem. I can even see people commenting saying they wish they were in high school so that they can get such experience. Yeah, it has been so insightful. Maybe we can hear some few words from one of our participants, Felix. Hello, Felix. Oh, I've just remembered that they were muted. But from the comments that I'm getting, they're all saying that it was such an insightful information, and they wish they were in high school. Yeah, so thank you so much for your your presentation. All right, so I think we can get into the next session, right? So if you have any, okay. So maybe we can unmute some participants to tell us how their session has been so far.
Hi, everyone. So,
Hello.
thank you very much for this opportunity. I would like to thank you, Prof. Main, for that wonderful introduction. Yeah, that was very noisy, informative. Personally, I think free exposure to college is a great idea. I once worked with Young Scientist Kenya to do some mentorship on technology. This is to high school kids, where we did train on Arduino. I guess that is the inspiration those in high school and primary school do need. For us, I think if personally I had someone to give me such information when I was still in high school, I think we would be next to China in terms of innovation, but I would complain we are still doing okay from our side. But thank you very much, Prof, for that session. I really appreciate for your time being here. Asante sana.
Thank you so much, Chris. I can see there's some questions that has been asked. From Berlin. Where is the question? Yeah, she's asking, have you had any programs? Have you had any programs and high school outreach programs in other countries? This is to Professor Maina.
Maybe I could answer that. No, we have not had any other outreach. This is where we are starting, and we have started in one sub-county. But I believe if this is successful, we'll continue opening up to both other counties and also other countries. What we intend to do is to make it as easy to do as possible, so that anybody having even read through the program can be able to establish the same in their own countries. And then maybe I can answer one more from, I think, Dan Mwangi, who is asking whether Royal Academy of Engineering is part of Murang'a University of Technology. No, Royal Academy of Engineering is an UK organization, and we only partnered. They were the sponsors of the grant, so we only partnered at that level of getting the grant. And we have partnered with them in various grants, not only this one. So that's the relationship we have with them.
Okay, great. There's also another question. This is from Nyokabi. She's saying the program is amazing. And is it open for student volunteers?
Wow, I think that can be organized. I think that can be organized. It's possible because we already did for student volunteers within Murang'a University, and we are aspiring to join IEEE as a sector. So I think that can easily be organized, so that we would want this to be spread to as much audience as possible.
For sure, for sure. There's one last question. They're saying, kindly, if the pre-college course could be extended to Njiri School in Kigumo, I'd really appreciate. There's a lot of talent there. Maybe you can look into that section too.
Yes, I think, thank you. I believe that is it was outside Kangema, but within Murang'a County. As we open up, I believe, because what was our initial seed money allowed us to target 270 students in 27 schools, but we believe if successful, the funds will be expanded so that we can go to the larger county. And I believe Jiri will be a target for me.
Great. I hope all of your questions have been answered. Let me see if there is another question. Yes. Yes, that's all the questions that have been there. We really there are more comments saying that they really appreciate the session that you have given us. All right. Thank you, Sana Professor, for the insightful information.
Thank you, and thank you again for inviting me to the forum. I've also learned a lot, and I believe I'll take the gospel back to Muranga University so that we can quickly join to be part of this great work that you guys are doing.
For sure. A round of applause, a round of virtual applause for him. I should also put some confetti here. Yes.
Thank you.
Thank you. All right.
Okay.
I can see that the Professor Chancellor representative, no, sorry, a student branch counselor from Strathmore University is here. Is that right? From Strathmore team is here. Fiona, why don't you just help expand on that?
Yeah, the Strathmore team have just logged in. Kindly, maybe just if you could unmute and say hi to us. Previously, we had the student branch counselor from Strathmore University, so we are also joined by another I think it's the dean. Kindly just unmute because I can't see your name quite clearly here on the participants. Just unmute. Go ahead and introduce yourself. Strathmore.
Thank you, host. Great presentations there. Thank you very much for the session. So I'm joined by Ian Kainan, whom we also work with here at Strathmore.
Hello.
So Ian.
Thank you, Steve. My name is Ayan. Can you all hear me?
Yes, we can. We can hear you. Yeah.
Okay. Thank you, Steve. My name is Ayan Kainan. I am a researcher or rather, I was a researcher, an intern researcher at IoT Lab. I'm also the branch chair of Strathmore University, and I'm glad to be here to participate in the engineering summit for this year. Thank you so much. Back to you, Steve.
All right, thank you, Ian. So I think we can continue with the summit. Once given permission, we can organize for a short session, and then I'll be able to share more about what we do, especially the works that the IEEE Strathmore branch has been doing together with the School of Engineering and the Innovation and Research Center here at iLab Africa. We have a very nice IoT lab, where similar to what Prof was saying about, we've also been doing some projects and some research work that I think it would be nice to share. So
Yes.
thank you for the opportunity. Thank you for the opportunity.
Yes, Steven, you can actually share right now. The platform is yours.
Oh, okay. Thank you for the opportunity. But if you allow me just to put together my slides, and then I can share tomorrow. I had requested for the second day of the summit, which is tomorrow, but today was just introductions.
All right. Okay, thank you so much.
If that is okay.
Okay,
yeah, thank you.
Okay, thank you. I can see I have to recognize the Dean, School of Engineering, Kenyatta University, Dr. Mambo. Dr. Mambo, can you hear me?
Yes, The host, Wagatune, thank you. I'm in the meeting. I joined a bit late, but I followed what my colleague, Professor Maina, has presented. I'm happy to be invited in this meeting or workshop, and I'll try to be in. Tomorrow I might not be in. I'm going out of town. I have an award ceremony for students, actually primary school students. So this is also an opportunity to tell them that once they get into secondary school, such opportunities are available. This is an eye-opener to all the students in our country, and we should embrace it much more. Just like Engineer Ahuna said, this is the first one, and we hope to have many more. We'll sensitize our students on the same wherever we meet them so that they can be able to participate in future. Thank you so much, Wakatune.
Thank you so much, Dean. Thank you so much, Daktari. Maybe you can talk about the IEEE in Kenyatta University.
Yes, we have a student chapter of IEEE at Kenyatta University, which is a very vibrant, very active chapter. It has a number of sections. I'm a patron of the Circuits and Systems Society. We have the overall patron for IEEE KU chapter is Engineer Martin Zomo, the former Dean School of Engineering. We have very active members. Currently, we have Alan as the lead, who took over from Fidel Makatia, and the team of Fidel, Alan, and the others have had so many achievements over the last couple of years. And they continue to drive IEEE KU chapter to greater heights. They are working from Chandaria Business Incubation and Innovation Center, and that tells you what they are up to. They have a lot of innovations they are incubating there, and this is the way to go. Like Dean Moranga said, we want to apply the fourth industrial revolution articles into all our working today, meaning that artificial intelligence, robotics, Internet of Things are the things to get into. And most of the innovations our students are working on are based on that. So when we get an opportunity to be trained to hear talks about the same, then we should grab it with both arms. We want to continue opening more sections of IEEE to be hosted. Recently, we had the Communications Society also actively having a function last week. And that is the way to go. Disseminate information, let people know what you're doing, and and share it widely. Thank you so much.
Thank you so much, Daktari. I can also see Alan Koech is here. Maybe you can say a few words representing Kenyatta University too.
Good morning. Can you hear me?
Yes, Alan, we can hear you loud and clear.
Thank you so much. Thank you so much. Sorry for joining in late, but finally I'm here. So I'm really happy that about what is going on today. I'm safe and I'm happy that we are going to learn stuff from this, and we are going to be able to grow our careers the next step. And to see I'm so much, sir, and thank you for joining us today. I'd also to engineer our all everything is going on as planned. And one more thing, maybe I'll just talk about before finished. Maybe can you share the
Alan,
screen from your end? Can do
Alan,
it from my end. Yeah.
your
Yes.
your signal, your connectivity is being lost a little bit.
Sorry. Is it now okay?
Yes, we can hear you well.
It's better now. Yeah.
Yeah. Thank you. So I want to talk about what you're planning also next, because we are trying to build our careers as engineering students. So this time we are having the engineering summit, which organized by the all student branches, as you have heard before. But next month we're also planning for an engineering festival, the second one, which we had last year, the first one. And I wanted someone to help me share the screen from your end, maybe Fiona, someone. I can't do it from
Yes,
my end. Yeah.
the technical team under Fiona and Mark will sort you out in a second.
Okay. So maybe let me just continue talking. Then once they share the screen, I'll just go on with it. So what you're planning for next month is the engineering festival. Second one, as I mentioned earlier, and we shall be focusing on matters for the industrial revolution technologies.
Alan, you have lost. You're breaking. We can't hear you.
We really hope that we may be able to teach you one or two things that you didn't know about, or show you some of the aspects or some opportunities that lay in front of us that we need to take use of in our different maybe projects or things like that. Also, we are looking forward to be able to connect students and young professionals to the market by bringing in those companies and manufacturing people in the market, those who are good in the market, those who are already established in the market, to come in and talk. And they can be able to know where to go next, because know where you're going next. So we want to connect you with the market, connect you with those people who are already outside there in the market, who know all these tips and tricks, and who are already established. Also, we want to give you a link or a connection between what you're learning now in school or in campus and what the industry expects you to have. So what you can see on your screen, that's our our event poster. So the engineering festival, the theme is actually engineering for the future, because you're looking at the future, and we are trying to look at the as I said earlier, the fourth industrial revolution technologies, which is an enabler for the future engineering. One of the topics I saw on the summit was about remote laboratories. This is one of the future technologies that we really hope that we can be able to help and change the engineering shape for the future. So some of these topics are very interesting, and I really hope that we can be able to, next month, we can be able to join again and learn new different workshops, technologies, panel discussions, as well as keynote speeches from people who have used these technologies to bring solutions in the different areas like the pandemic that we are currently in, as well as things that we're planning for the future. Like we are now talking about the electrical vehicles in Kenya. So we already have players in the country who have already gone a step forward in trying to achieve this. So we're going to bring such people onto the festival to try and show you what they are doing and how you can go to maybe get in touch with them and join them in their quest to achieving these different goals. Yeah, with that, I don't have much to say. I just welcome for that for next month. And from my end, from IEEE KU, welcome to the Engineering Summit as well. Thank you, and back to you.
Thank you so much, Alan Koech. I hope everyone has saved their date on 6th to 7th August 2021. There will be an event at Kenyatta University. Their theme will be Engineering Festival, the engineering for the future. All right, so we are almost getting started with the panel discussion, but as we wait, let's get a short break for just 7 minutes. The technical team will present some entertainment videos, and then we'll start off at 11 a.m. That is 7 minutes from now. Okay, as the videos are being presented, maybe we can have a few conversations with the participants here, just to hear what is their experience so far, how they have seen the summit going on. I can see Ravin. Ravin, are you here with us? Hello, Ravin, can you hear me? All right. I can also see Victory Muthoni. Victory Muthoni, are you here with me? Yes, Muthoni, can you hear me? I think I've just heard you. All right. So I hope the technical team is ready. We have 5 more minutes before we start the panel discussions. Maybe you can give us some few entertainment videos as we refresh and come back into the next session. I don't think I can hear any sound. Technical team, why don't you put some sound to your video? All right, welcome back. We just had a short break after a captivating presentation from Professor Minor. The topic he was talking about was pre-college exposure of engineering to high school students using robots. So if you missed that session, don't miss the next ones, and be ready for more and more interactive and captivating discussions and presentations. All right, so we'll get into the next session of today. We'll be having a captivating panel discussion led by moderator Collins Osoro. Collins Osoro, are you here? Collins Osoro? Okay, before he comes, maybe I can introduce him. Yes, hello, Collins. Collins Osoro? Just as before he finishes preparing, maybe I can give you the topic of discussion. So the topic of discussion is engineering taking its shape. This is our first panel discussion. Collins Osoro is the director and founder of Exergy Technologies based in Nairobi. Hi, Collins. Can you hear me now? I think there's some technical issues. Maybe moderator Moses Bore can take over. Moses Bore, are you here? So because of technical issues, we will have moderator Moses Bore to moderate in the first panel discussion. Or Collins, Collins, you're here? Collins Osoro, kindly unmute yourself so that we can start the moderation, the panel discussion. All right. Moses, I can see Colin saying, can someone hear him? No, we cannot hear you. Kindly unmute, or the technical team and Mark Ngugi can help you out. So anyway, as Collins tries to figure out what is the problem, maybe I can hear from Nyokabi Waweru. Nyokabi, how are you doing?
Hello, hi Wagatume. I'm doing well, and you?
I'm doing fine. We're just having some technical issues, but how is the summit so far?
The summit is great. The first session was really good. I think I would say after listening to that session, like someone said, I wish I was in high school again because I would definitely go through. Okay, I think you can hear Colin.
Yes, Collins. I do, I cannot hear him. Nyokabi, you can continue saying what you're saying as we wait for him.
All right. I was saying, I think as someone had said, after that session, I wish I was back in high school because I would definitely do that program. It would help in a lot. I feel like I would even know a lot more than I even do right now, like the fact that I'm in fourth year. But it's good to see. It's good to see that such programs are coming up, and yeah, I'm loving it so far. Yes.
For sure. You can imagine being put in a mindset a structural mindset where you start from, what if we did not have engineers? And we're in that generation, we call it Gen Z, where everyone is using their phones. So imagine not having phones or the internet, you know.
Yeah, it would be crazy.
For sure. That was an interactive discussion or presentation from Professor Minor. If you missed it, well, don't miss out in the next ones. So I don't know, Collins Osoro, are you here? Are you here with us? Okay, as he tries to, I can see he still has some technical issues. Maybe we can continue having a short conversation as he tries to figure out the problem. I can see no. I can see Kennedy Rono. Kennedy Rono, are you here with us? Hello, Kennedy. Can you hear me?
Hello.
Yes?
Please tell me you can hear me.
Yes, finally I can hear you,
Oh
Fiona.
gosh, I'm so sorry. You see, I don't know if you've heard of Murphy's Law. I think Murphy's Law just happened. I don't know if you guys know about Murphy's Law. Does any one of you know about Murphy's Law? Please just unmute, or if you've experienced Murphy's Law before I just say what Murphy's Law is, because it has just happened. So what Murphy's Law states is that anything that can go wrong will go wrong. So that has just happened in the past 7 minutes. Anything possible that could go wrong just went wrong. But it's okay. We do something called, when you're a leader, you do something called disaster management, risk management, all those kind of things. You get to learn about them. So I can see our panelists are here. I can see Samuel Ndaro from Boeing. I can see John Matogo from IBM Africa. I can see Andrew from Swift Lab Limited. Guys, yeah, we just done some disaster management there. So I will briefly ask Samuel Ndaro. I hope I have not got anything wrong. I'm not sure if it was Engineer Samuel Ndaro, so apologies. Just quickly introduce yourself, a brief introduction, tell us who you are, what you do. And then after Samuel Ndaro, we'll go to John Matogo. Just a brief introduction, then Andrew too. Thank you.
Good morning, everybody. Yeah, engineer by trade, so engineer Samuel Ndaro. Currently working at Boeing, originally from Mombasa, Kenya. Actually, my high school was in Alidina Visram in Mombasa, so immigrated to America a couple of years ago. By trade, my bachelor's degree was in aerospace engineering with a minor in mathematics. And then I have a couple master's degree, one in engineering and then one in business administration. And then working-wise, I was privileged enough to, you know, as engineers, you grow up and maybe you want to design, do the analysis, the calculations and things like that. But I think what makes a better engineer is somebody who can actually do the hands-on of the actual product, right? So I was blessed enough that I was able to do or have a hands-on experience working with the helicopters in the military. And then by trade, I started working at Boeing on the 787, designed a couple elements of the 787. We won't go into details on that. And then on the space launch rocket, the one which is supposed to be going to Mars too, did a couple analysis, engineering, and work there too. And then I moved into management role, managing engineering teams and things like that. And one of the interesting things that I did as a manager was managing an MRO or a post-production team. So that's a little bit different, right? Because when you think about design, you do the initial design and then you almost have a free will in what you're doing. When you think about a post-production product, you're limited in what you can advance in terms of technology and innovation in a product that is already being used. And then I'll jump to my final role. So when you think about innovation and you think about sustainment and you think about the future, my current role is leading a team that is thinking about those things, thinking about where Boeing will be in the future, thinking about how we're going to sustain those products in the future. So we're thinking about things 10 years out. So the stuff that I'm doing right now, a lot of us are not going to see it until maybe, or hear about it until 10 years from now. So it's pretty interesting. It's pretty cool. You're thinking outside the box. You have to kind of switch on that innovative mind in order to be able to think about that, right? So, hey, that's me in a nutshell. So looking forward to a great discussion. Thank you.
Thank you so much for that, Engineer Samuel Ndaro. Thank you for correcting me. Now we'll go to John Matogo. John Matogo, just unmute yourself and give us a brief introduction.
Hello, good morning, everyone.
Good
To
morning.
the organizers, thanks for putting together this meeting and for inviting me to this session. It's really a pleasure to be here and to be part of this session. My name is John Matogo. I work for IBM, responsible for global university programs on the African continent. What we basically do is work with our academic partners to enable on new and emerging technologies. The previous speakers talked about the fourth industrial revolution. So what we are doing when we engage with our academic partners is really give access to students and faculty to these technologies, so that as you go through your academic program, you're able to use, experience these technologies. So with the intention that as you start your career, you're also familiar with this technology, and not just from a theoretical standpoint, but you also actually have used them practically. So when you get into the work environment, be it your own initiative or maybe in employment, you can be productive from day one. So we do this by giving all of you access to IBM Cloud and various other IBM technologies for this purpose. By way of background, I'm actually an alumnus of University of Nairobi, so it's good to always engage with the University of Nairobi. And as an IEEE active volunteer, I also I'm happy to participate in this kind of event where we are working with the student branch organization. So looking forward to an engaging session, and also happy to be on the panel with colleagues here. Thank you.
Thank you, John Matogo. Thank you so much for that. Anderito, are you with us?
Yes, I am. Thank you so much. My name is Anderito. I'm a co-founder and Chief Operations Officer at SwiftLab. So SwiftLab, we design, build, and operate drones. And our aim is to make Kenya a manufacturing country, because previously what we've seen in the drone industry is that most of the big companies, or most companies that do big projects for government, they're not African companies. So Africa just becomes like a testing ground for these companies. And at the end, we really do not build our capacity as engineers, and it just becomes operations. So we want to change that narrative. Yeah, I'm very excited to be in this forum with other panelists. I think I'll learn even more, and happy to see some from Boeing. I think Boeing was one of my dream companies when I was in campus. So I'm very glad, and yeah, look forward to this conversation from everyone. Yeah, thank you.
Thank you, Anne. So maybe some rules. Okay, let me just mute everyone right now, and then I will selectively, I've just muted everyone right now. So what I will do right now, I want to just unmute only the participants in the panel. So let me do that right now. So because of noise, let me just unmute the participants. So what I will do, I will request you to unmute. John Matogo, I've requested you to unmute. Engineer Samuel Ndaro, I've requested you to unmute. Anderito, I've requested you to unmute. So please confirm you've been able to unmute.
Perfect.
Okay, Collins Osoro, I've requested you to unmute. Have you unmuted?
Absolutely.
Okay, kindly speak so that we can hear you.
Hello, can you hear me now?
Yes, now I can hear you. Welcome, Collins. Now the floor is yours.
Okay, thank you very much, Fiona. Network issues. And hi to my panelists. I'm very happy see John. Hi, John. I'm very happy to see some that we've interacted before on LinkedIn, and Andre too. So I just want to welcome you to this session of IEEE. Like my colleague has mentioned, it is how we are going to begin in this format. So it is a generic format for the question and answering. And so the very first question, which is an open question, and I direct this to Engineer Darrow. I don't know, Engineer, in your opinion, what would you say is the best period in the history of engineering?
Everybody hear me?
Yes.
So I'm going to be a little bit biased because by trade I'm an engineer in aviation world. So my responses are mainly going to be based or kind of related towards aviation world, right? So you're asking about the history of engineering. You know, back when Bernoulli's whatever laws of engineering were being created, we made a lot of assumptions, right? So a lot of assumptions, and we know in engineering, any kind of formulas or analysis and anything, you based everything on assumptions. So when you think about the current world where we are, engineering has moved so fast that now we're starting to think about, hey, when I make those assumptions today, what will happen tomorrow, right? You need that feedback back to be able to see from your results whether those assumptions that you made, do come into reality. So that brings me to the amount of data that we have right now. That's why I call this the best engineering time, the amount of data that you have. You think about digital thread, when you create data in the initial design phase versus at the end where you consume that data. You have that ability to be able to stitch this data from the creation point to the end where the data is being used. And then you think about creating a digital twin of the actual product that you're utilizing, right? So you have mimics within an analysis that you can create data within data to be able to create a loop of feedback to get the data and get the results of the data or the things that you're trying to do. A great example is an airplane, right? When you design an airplane and you have it out in production and flying, right? Now I can be sitting somewhere around the world and be able to exactly know how that aircraft is performing. How sweet is that? I think this is the greatest time in terms of technology. And this technology is only going to get advanced, right? So we still have a lag in the feedback in terms of an aircraft is flying in Kenya and I'm sitting in the States and wondering what that aircraft is doing. Yes, we do have that digital twin, digital representation of that aircraft, but I think with time, 5G coming along, I don't know if we're going to go to 6G and whatever technology that is out there, but you think that the representation of that data will be instantaneously. That's what we're shooting for, and I think that's why I'm so excited about the current technological advancements that we are. So this is the best era. Anybody in school, help us out to get there so that the future can even be greater. Thank you. Any questions?
Absolutely. And thanks a lot. I just need to tie this, engineer, to this aspect of innovation. And as you found about this question, of course, how has Boeing, for example, encapsulated in innovation? We understand, especially right now when we're in a pandemic and there's been a lot of disruption in terms of travel and so on. So how has Boeing, for example, adapted into real-time innovation? And this question will also go to John. So as Engineer is also responding, I also request John to also just think about it, about real-time innovation, especially in this period of the pandemic.
So real-time innovation, right? So there are certain things that you can get away from, those interpersonal interactions and things like that, right? So Boeing has been great in terms of taking care of the people and the safety and everything, right? Wearing masks, sanitizing, vaccinations, and all these things. So those things have kind of enabled some of the teams to be able to come in and be able to sit in a room and have these discussions and these innovative ideas, juices going, right? And then other than that, we have tools within the companies that virtually we can use and kind of continue with those innovative ideas or innovative juices during discussions and meetings and things like that. It hasn't been easy. I won't lie to you. Nobody expected this, in a million years. It comes once in a lifetime probably. So there was a lot of adjustments initially when we went through pandemic, but now, we've kind of learned from it, adjusted from it, and we're finding ways in which we can engage teams. We have similar discussions, lunch and learns. We have panel discussions like this where people are going in and kind of having those innovative discussions and ideas within the company. So it's tough. It's not easy, but we're trying our best to do it. And you can't get away from human interaction. So right now we're trying to go back on a phase approach, and those who are vaccinated and things like that, just for us to have discussions on face to face. Thank you.
Thank you very much. So John, you can just jump in. In IBM, we've had a lot of trajectory in terms of how moving work from home and so on. We've had to look at some of these systems and the integration of that, and also the adoption of the workforce. So John, just in a snapshot, how would you rate innovation as far as IBM is concerned?
Thanks, Collins, for the question. And to respond to your question, I think one of the things that I think a place like IBM that we've been sort of privileged or maybe fortunate to already have done is really have this culture of innovation as part of our this is part of IBM's DNA. Just last month, IBM was celebrating 110 years of the company's existence. And one thing that you'll realize is that throughout this 100-year plus history of existence, IBM has had this tradition of, being at the forefront of technology innovation. So I wouldn't say this is something new. This is something that has already been practiced and has been a tradition in the company of, always thinking about the future. So we're not really developing technologies for today and now. We are thinking, 10 years ahead and so on. So actually, just tying this to the question that you asked at the beginning, what would you say are defining periods of where in the history where there have been defining for technology innovation? I wouldn't say I agree with some that now there's a lot of very interesting stuff that's happening. There have been some interesting milestones in the past that have let's say leapfrogged society. If you look at when computing was brought to the desktop, I think that is something that is quite important because that transformed a lot of things. We're having artificial intelligence. Recently, we showcased quantum computing, and then even more recently showcased our innovation of the nano chip. So, these are all interesting times. We're having a lot of great breakthroughs that are coming up. But it's only going to get better, in my opinion. We'll see technology playing a bigger, more significant role. And I think that just opens up the frontiers. Sam was talking about, space travel. So I think with all these innovations, all these different breakthroughs, it just opens up the frontiers of different capabilities. Regarding the question about working from home, I think as IBMers, we had been working from home many, many years ago. In fact, I think before the pandemic, there was some executives within the company that were trying to get people back to the office. But now, obviously, with the current pandemic, now everybody is working from home. So it is something that the working from home has not been something strange for us. It was just a continuation. The only challenge has been, most of the clients, most of the partners we work with, and also now coming to terms with the working from home phenomenon. But I think everybody has been quick to embrace this. In terms of, I think, what would enable innovation to thrive is a change in mindset and also adoption of a culture of agility. So, we have, a framework or maybe a way of working, which is called Agile. And the idea for this is really to try out things quickly and then pivot if we need to, or make changes and adapt as quickly as possible. So I think this would be useful to fast track innovation. Thanks.
Absolutely, thanks, John. And I would go to Anne Underichu, and having founded, being a founder of Swift Club, this is something that you developed from scratch. And I just want you to paint a picture for us about what are some of the gaps that exist, that are existential between the industry and what is taught in class, being a co-founder, and going through all the experiences, founding a company and so on. So, just paint a picture for us. And as you do that also, I'll request John, because John works for, deals with global universities. And that is a major challenge in terms of what is taught in the classroom and what is happening in the real ground. So, Anne, kindly.
Thank you, Collins, for that question. It's a very good question. And as Sam had mentioned earlier, I think the very foundation or the very basic thing about engineering is building. So I think as engineering students, what they need to consider is how can you be able to get skills to build things, and that looks very different for each career and each field that you're in. If it's an electrical engineer, that's something different. That's something different. If it's an aerospace engineer, does it mean you can be able to design an aircraft? Can you be able to build? Can you work on avionics? So most of the students, I think, or what the current programs in university, they really focus on the aspect of theory, and so students miss out on aspect of having practical skills that they can actually apply. Because as an employer, when you come to my company, I want to understand what can you be able to do in the company. That's like the very basic question, even before we go to other interesting interview questions. But what can you be able to offer my company? So as a student, always focus on the skills. The skills are really important. They will take you forward, and yeah, they'll actually build you before you now start moving to the managerial and leadership positions. So as a startup, founding a startup in Africa is a whole lot of things. But basically, what we're focusing on right now is our product development. That's really essential. The designing of the drone, making sure that actually the product works and it delivers to the customer's needs. And then now, from then on, is moving to the commercialization stage, which requires a lot of capital and a lot of goodwill from the government in terms of policies and the licenses that are needed. And that's the phase that we are in. But right now, we're glad we've already done first prototype, and we're building our second prototype, and have done a couple of tests. Yeah, we've done a couple of tests, and actually last week on Friday, we showcased our drone to the president, His Excellency Uhuru Kenyatta, at Konza Technopolis.
Congratulations, Anne. And John, I just come to you as you answer that question, John. You also look at, we're moving into the fourth industrial revolution, and Africa significantly missed in the first, second, and third. Talk of AI, talk of machine learning, talk of these are some of the things that IBM has really championed as far as I'm concerned. So as you answer that skill gap, also, what would you advise a young engineer going into some of these places? What do they need? What is the basic plan that they need to have even just before going into this?
So what I would say would be mean, this sort of skills gap that you're referring to between, I think there's a bit of a disconnect between the expectation of what a graduate from, let's say, a university course and what the industry is expecting. Remember, when someone goes through a university program, they're going through a 4-year program of a curriculum that was developed, maybe 6-7 years before, right? Now, the thing is that when that individual graduates, when they join the workforce, and they join a company like Ann's company, they have expectations that this individual is then able to become productive on the challenges that are faced or on the needs that the company is trying to work on, which are now. So you see there's a bit of a challenge there because the curriculum that they were in was designed 7 years ago with the context of 7 years back, but you're dealing with an issue that is at present now. So this is the challenge, you can say the disconnect that happens between someone who's coming out of an academic program and the need that is there in the industry. So how can we then address this? So this is why organizations like ours, what we do is then reach out actively to the academic partners, universities, like which most of you are, and say, let us then see how can we bridge this gap and close this disconnect that is happening. So what we do is try and plug that by making available the same technology that we sell commercially to companies like Ann's company and others, so that as students go through the academic program, which is good, by the way, so there's a lot of skills and a lot of practice that they gain during that program, but we also are able to equip them with practical capabilities on the real requirements that are there in the industry as of now. So if you look at any curricula that is in there in any university program, I would bet that there are no topics like AI covered in it to the depth that you'd expect. Someone who is major industry is expecting them to. Topics like cloud are not covered there, blockchain, IoT, and so on. Which, when they graduate from industry, you had the colleague from Boeing talking about that they need data from the plane. This is what is expected. They want individuals that can actually develop solutions that will capture that data. They need analytics skills and so on. So if you look at the curriculum, this is not addressed, but in the industry, this is what's expected. So when we bring programs to the university, we try to bridge that gap by way of certification or trainings that would then help skill up these individuals on those technologies that are there in demand in the industry right now. The other thing that I would say, I mean, in terms of what is expected, is also really a mindset to give solutions to challenges that are expected, that are there. I mean, in my opinion, yes, I think someone mentioned that an engineer is expected to build. I think an engineer is also more expected to solve difficult problems, right? So this mindset of going in there to solve problems, I think, is something that is hugely important and very attractive for people who are in industry. I hope I've answered all the questions that you have asked, Collins.
Absolutely, John. That is fair enough. And some of these programs that IBM runs through the Digital Nation Africa, which I have to declare interest that I've been a beneficiary to that program and having worked for IBM. So these are some of the opportunities that are out there. So I'll go next, and I'd wish to invite Engineer Ndaro. This aspect of robotics coming in, and Boeing is a very massive organization. Assembling structure and completion, everything. And robotics come in very handy to enable, some of these processes run seamless. And my question to you would be, what, or in what sense would you rate, robotics, and what is the position of, an ordinary engineer who is in school right now, and they're transitioning into the job market. They want to get in there and have, their way, give their opinion, and then we have robotics coming in. And especially in some of these massive companies. So what would be your position, especially from where you sit at Boeing?
So robotics, right? So robotics, you think about, and I think if I miss any part of your questions, please just repeat it to me at any point or ask for clarification. So you think about robotics, I think there's still, we haven't got to a point where the human interaction is going to be taken away. We still do have that human interaction with the robotics, right? So as a design engineer, and analytics, anybody else, somebody has to design that robot, right? So that human interaction will be there. And then when you think about in a manufacturing plant, when for example, you're putting together a 787, there are certain processes or procedures in manufacturing that, for example, you have to install 1,000, rivets or fasteners or bolts or things like that. I don't expect humans to go in and do that, right? So the technology has advanced in such a way that you can use, for example, design analytics. You can use the most advanced manufacturing technology that is out there to have precision in how those holes are drilled, and then to have precision in how those fasteners or bolts or rivets are installed. It's a time factor, because if I have to install 1,000 bolts, the robot is going to be faster than a human, right? But I'm not saying that take away the jobs from the humans. What I'm saying, I think John kind of touched on it, we adapt to what the technology does for us, right? So the robot is going to install these 1,000 rivets, but the robot is not going to think for us, right? So the mindset is for the engineer, the mechanic, to be able to think for the robot, right? You have to adapt to those situations, and you have to be able to leverage the use of robots and the interaction of humans in creating technology. That has to be there. And I think John kind of touched on agile and things like that, right? So when you think about working in an agile environment, right, you go through these sprints and you go through these technological advancements and how fast we can do that. You use software, you use robots, and you use humans. That interaction has to be there in order to keep, the agile methodology, to keep the sprints going, to keep the advancements in technology. It's a weird interactions. We're starting to adjust to, maybe companies like IBM have figured it out, the software with everything like that. They're a little bit advanced in terms of that. But, in a manufacturing setting right now, we still have that human interaction there. When we're getting there slowly, but my analysis will be, hey, the humans will still be involved. We just have to adjust and adapt to the current situation and the future situations of where technology is taking us. I hope I answered all your questions.
Absolutely. And I would also wish to go to Anne again, having come up with a startup, developed a concept from scratch, and being able to now move it into the next level that it is. What is, or how can you relate the demand in this market, especially the locally produced items and goods? And I think John as well can weigh in. IBM has been in manufacturing for a very long time. I think they have been invigorated right now into research. And so, as Annie to answer this question, what would you rate, or what would you, what is the achievement of the force behind engineering, and what is the the cost attached to it, and how does it achieve in the market for?
Please, colleagues, could you just come again? The last part of it.
Right. I'm saying, what is the value proposition in terms of what engineering brings into the economy? And as a driving force, engineering is a very big enabler in anything that happens. Infrastructure development, you name it. Engineering has to be at the core and the center of it. So, what would you rate, in terms of building the economy and really just stabilizing and being an enabler?
Okay, yes, thank you for the question. I think, as you've already mentioned, that manufacturing is a very important part of the economy, and one way to look at it is the job creation aspect, because with manufacturing, we can be able to bring jobs in the country and actually also expand the ecosystem of the said field. So, for example, here in Kenya, we already have 10 if you import a drone from outside, you are taking
I think
industries in the economy.
we have a back.
Yes.
Yeah, sure. I think we had lost you for a moment. So we have
Okay, yeah. So was just saying about the job creation, and once having manufacturing in the country means that we are creating jobs for graduate engineers, and these just improving the people's lifestyle. Okay. So second, also in terms of industrialization and expanding the ecosystem. So by us building drones locally, we are creating employment for other industries and expanding the whole ecosystem. So
I don't know. Could you kindly check on your audio? Not able to hear.
She might be muted. Maybe someone can unmute.
yes.
Yeah, sure.
I think
You know
you
my
should
host proceed.
Okay. So sorry for that. Okay, so manufacturing, number one, is it brings employment to the country. For example, for us, we've been able to employ 10 graduate engineers into the company, and that tells you that's just in building one drone. So the moment you go to import a drone from another country, it means that you're actually taking away jobs from the engineers here locally. And this just shows the great effect of bringing manufacturing in the economy, and can't be compared when you import and just offer services, because as I'd already said, it also creates capacity building, and then there's a multiple effect in the economy that cannot be ignored. Yeah. Then secondly, also is about industrialization, as you had touched. Through manufacturing is that you touch on other economies in other fields. So in addition to that, you're also creating an ecosystem, and it kind of expands and affects even other people. I don't know if there's another part of your question that I've not touched on.
Absolutely. You've been very exhaustive. Thank you very much.
Okay.
Maybe John can weigh in just in 10 seconds.
Yeah.
Listen.
Yeah, thanks. So just to add on what Anu said, for me, one thing that is very attractive, and I say this, I mean, knowing that there are a lot of engineering students listening in, is that, one of the things that as an engineering student, you have already demonstrated the ability to really go through a lot of rigorous a rigorous process of learning something and then using that knowledge to really solve a problem. And this is why I always think of engineers as problem solvers, right? And knowing that you've got a pool of problem solvers and solving really difficult problems is very important when you're trying to develop an economy. And in our case, I mean, in our context here, we're in Kenya, so we are a country that is developing. So having a pool of engineers is extremely important because what you then have is individuals who can solve difficult problems, and this is very good. What we now need to do is to, number one, put these individuals to work, and also enable them with the technologies that are useful in this day and age. So you're talking about the fourth industrial revolution. So as engineers, then can they then skill up on the technologies that we want to that are useful in this day and age? So if you're talking about artificial intelligence, blockchain, IoT, etc., so that they can use this technology to solve the difficult problem that exists in society, be it in agriculture, be it in healthcare, and whatever sort of field you're talking about. And then the mindset to actually go out, identify those problems, and begin developing contextual relevant solutions to address those particular challenges. This I think, is the value of engineers in a particular society. That's what I would say to respond.
Absolutely. Thank you very much, John, for those comments. And I'd like to return back to Sam. So Sam, there's been a problem in terms of policy, and let's talk about policy development. Some of these things are championed by people who are not experts. If you talk, for example, about legislation, if you go to the MPs, not all of them are experts in terms of engineering in any profession. And I just want to know, and especially comparative to the Kenyan market, or rather Africa at large, and what is happening in the US. So would you say policy is an impediment, and how can some of these things be turned around so that at least other people can get an opportunity and be able to champion their ideas and we get the right policies across? I think you're on mute, Sam.
There we go. Yeah, great question.
Absolutely.
It's a difficult one, and these are going to be my own personal views, right? So, and probably John and Anne can respond to the Kenyan aspects of things. So, we just recently went through a transition of changing presidencies, right, from President Trump to now President Biden. So, each one of them had an idea of what America should be doing in terms of technology, right? And they probably have a bunch of advisors with them who are giving them advice on where America should be. And you touched on, Collins, you touched on, do some of them understand the policies? What the presidents in America have done a great job is trying to surround themselves with maybe a separate entity within the government that they're saying, hey, I'm bringing these business people, these technological people to come in and have those discussions about technology and where engineering and technology should go. So half the time they do take advice from them, and I think half the time those sessions have led into advancements in technology. A quick one, digital thread, digital twin, blockchain, John kind of talked about it, 5G and all these things, IoT. President Trump kind of focused on those, and we as Boeing had to react to that, right? So John talked about, interaction with the schools, interactions with the community and things like that. We had to adjust to that and be able to leverage and pass some of the aspects to the schools, to the community, for them to be able to help us in terms of advancing those technologies. So they come in and they help us out, and they come in from day one, they'll be able to work within the company. And then when you talk about the current new administration, they're focusing on cybersecurity and things like that. That's the first few months, that's what we're seeing from Washington, that, we had all these hacks and all these things that were going on through elections and stuff like that. So that's the immediate reaction of what we're supposed to be focusing on. And then when you combine all these things, right? Again, I go back to the aviation. You combine all these things. An aircraft is flying. You want cybersecurity. You want that airplane to be secure. You think about 5G. You think about blockchain. What can that technology do to an aircraft? So sometimes maybe the technological advancements or discussions are going in a different direction from what engineering and what field you are in engineering. But like John said, we're problem solvers, right? So you give me a problem, I'll figure out how I'm going to be able to fix it to my current entity of engineering, be it computers, be it motor vehicles, be it airplanes, whatever it is, the cybersecurity, I'll try and fit it in within whatever I am doing. So good and bad, but I think if you surround yourself with good people, they'll always advise you on where technology should be going. I'm not sure about Kenya, but I think I'll leave John and Anna to kind of touch on that.
Absolutely. And I'll go to the very last question and then give each one of us, as we respond to this, to give our closing comments on the same. It's about what your thoughts could be about how engineering is taught in class and how it is practiced on the ground. Is it the best approach? Is it the best formula we are using? Or are there any changes that we can inculcate and be able to reinvigorate all these processes so that at least where we get to, and especially in Africa, we get into the pace that other economies across the globe are. So I'd begin right on my left with Anne, as you give us your closing comments, as you answer that question.
Thank you, Collins. I think first I'll comment on the policies that affect engineering in the country, and I think policies are very key in terms of the engineering and the industrialization space in the country, because they can actually kill or make the industry thrive. For example, in the drones industry, it has been a long journey coming up to this point. The drone regulations were just published last year, and that was after a long time. So literally, the country business, you couldn't do any commercial drone operations, and that was a very big limitation on our end as innovators. And even after the policies, it's still, even after the regulations were published, it's still taken us a while for us to get the approvals, and we just got that at the end of last month. So policies actually really affect the engineering and manufacturing industry. And as a country, I think we still have a long way to go in terms of making it easy for innovators to thrive in the country. I think also something else that really affects is the ease of doing business, because you're actually building so that you can be able to sell. So if the ease of doing business is not very good, then it deters people from getting in the industry. So on the last question on how we can on how engineering should be taught, I think as I had mentioned before, it should be more practical based and try to understand the needs of the organizations that are already in the industry, because those are the organizations that the students will go looking for work. So try to align your programs, your courses around what the market needs. That way, the students have an easy way of transitioning to the careers. Secondly, I think as John had mentioned about creative thinking, making sure that students or engineers can be able to solve problems, because every day as an engineer you will be met with something different that you've not seen before. So being able to think creatively and coming up with new solutions. Also very important should be learning how to learn, because every day the technology is evolving and we have something new every day. So you can't have a you must have a growth mindset and be ready to learn new things. Then schools should also be ready to implement new technologies. I think like what IBM is doing. Try to learn the new technologies that are in the market, machine learning, AI, blockchain, all of that, introduce them to the students. And I think once the students know that such things exist, they can even go out of their way to get more knowledge. Yeah, so my closing remark is that I'm excited and I've learned a lot from other panelists. And yeah, wishing all the students the best as they enter into the job market. Thank you.
Thank you very much. Thank you very much, Anne, and for your time to join this panel. I'd go to Engineer Samdaro. Please, as you answer that question, as you also give us your closing comments.
Yeah, it's been a pleasure to be part of this panel, Esteemed John and Anna. I mean, great answers, great discussions and everything. And then just being able, I left Kenya, right after high school. So being able to engage with university students like this, it's really humbling for me. I do it locally here in the States. I'm heavily engaged with the local communities, mostly in the African American communities, just trying to push STEM, trying to push engineering and things like that. So it's been a great pleasure for me and humbling experience going through this. All right, so how should engineering be taught in the future? My personal opinion, again, having been raised in Kenya, your parents put expectations on you, right? They put expectations. I want my son to be a doctor. I want my son to be an engineer. I want my son to do this. I want my daughter to do that, right? It's not for everybody. If you do not enjoy engineering, you will struggle when you get into the industry, and that's where issues come around, and then we don't have good engineers. So, first of all, to the students, if this is not for you, look inside, deep inside, you will know this is not for you. To be an engineer, you need to have passion, you need to love it, and you need to want to do it. The monetary aspect of being an engineer will come later, but the creative mind, the wanting to learn and things like that, you have to have it in you to be able to become a good engineer. So that's for the students. And then for the learning, I think for the learning, what I would like to see change is not everybody learns the same way. Not everybody goes to class and can go through a vigorous curriculum and be able to grasp everything. Some people are better in practical. Some people are better in visual. Some people, take notes. It's just a difference. I wish that, the learning material will be more competency-based in such a way that a mixture between self-paced and obviously there has to be a curriculum that everybody should follow, but self-paced, competency-based, and things like that. I think that will be a change. That's where learning is going, right? We see how we train pilots, how we train mechanic in the States. Not every pilot is the same, so we have to adapt those curriculums to an individual. And I think with some of the things that IBM are doing right now with the learning context and things like that, you partner with them, they can provide content that is based on your ability to learn. Not all engineers are made the same, but if you have the passion to be an engineer, there is a place for you in the engineering world. That's where I think learning should go in the future. So thank you very much.
Thank you very much, Sam. And it's been a pleasure to hear from you and hope to connect even more as we interact in some of these sessions. And then lastly, I'd go to John, just as you answer that question, as you also give us your closing remarks as far as this session is concerned.
Thanks for having me on this panel. So just to answer the question, how should engineering be taught? I don't think this is an answer we can have here. It's a discussion that involves many more stakeholders. It's a bigger question that might need to be addressed in a different fora and also with different stakeholders. But I think let's look at what is within our grasp. What's available to us. I would advise the students go through your academic program, yes, because there is certain skills that you get going through that rigor that you are learning as you're learning your engineering program. That is perfect. But then also be on the lookout for other learning opportunities that are available to you as a student. So I've shared on the chat learning resources and opportunities from IBM. So complement your academic program with offerings from IBM. Make sure that you are able to upskill yourself on all this discussion around the fourth industrial revolution technologies, so cloud, artificial intelligence, blockchain, and so on, because this will help us to then provide solutions using your engineering experience and knowledge that are relevant in today's context. And not just from IBM. I'm sure if you open your eyes and look around, there's lots of other organizations that are providing you with opportunities to learn skills in different areas. And soak up those opportunities right now, because you're really investing in yourself for the future. The other thing that I would say is develop in yourself the interest and the mindset to go out there to solve, look out for those difficult opportunities, difficult challenges, and then develop solutions. Really, that is really what you as an engineer are, let's say, trained to do. That is what society is expecting from you. And during the time when you're on taking academic training, look for the opportunities like those. I mean, you have a lot of opportunities for hackathons on campus and so on. So, you know, immerse yourself in those opportunities where you can then get the experience of identifying a problem, developing a solution, and then as you develop that solution, look for frameworks. We talked about Agile, we talked about design thinking. These are ways that you can build the skill of innovation, of developing solutions. Other things that you also get to do, which are also important, is collaborating. So identify colleagues and other individuals who might not have a skill set similar to yours. So you might have others who are good on the, let's say, the business side of it, or on the design, whatever the case may be, but you then learn to bring together different skill set to address a common problem. So I just share with you an opportunity now that I challenge you to go out there and try it out. We have a challenge called Call for Code that is going on right now. And this is a challenge that has been launched. It's a global challenge. And the theme of this year is to address challenges around water, clean water and sanitation, zero hunger, and responsible production. And these are challenges that we know in our context in Kenya are really important things. And you as an engineer, go back and think, with all my engineering knowledge and skills, how can I develop a solution to tackle the problems that we face in Kenya regarding clean water and sanitation? And then you go back as a team, get colleagues, bring them together, and develop a solution around that. In the process, you learn very many skills. In the process, you are able to come up with a solution for something that is real, that is affecting all of us. And if you are lucky, you could win the prize that is there, and launch. That could be a springboard for your career going forward. But I think more importantly is what you'll have learned within that particular process. That is a way in which I would say that is within our grasp. We can change the way the learning that we get the learning and get the skills that are relevant going forward. So I hope that's useful, and thanks for having me on the panel and to be part of the team with Annie and Sam. Thank you. I hope we could also have some questions from the audience, Collins, if possible.
Yeah, John, that would be great.
Collins, I think it's back to you.
Thank you, John Matogo and Engineer Samuel Ndaro and Anne for that. We really appreciate so much. So anyone with questions? Any questions? I can see Caroline had commented on the chat box. Caroline is saying this is indeed a humbling experience. Thank you. Maybe Churchill, can you unmute and tell us from this experience, what have you learned? Churchill?
Thank you very much. It has been a very informative experience. I've got to learn a lot. As much as I'm doing civil, I've also learned about, majorly what was being talked about, I believed was on IEEE and maybe a bit of mechanical. But yeah, the policies, how policies affect engineering. Yeah, it's been quite an informative session.
Thank you so much, Churchill. Churchill is a civil engineering student from University of Nairobi. So this forum is open to literally everyone who's interested in technology and how they can apply these technologies in their field. And anyone else who wants to make a comment on this from this session, what you learned. I can see there's someone here called Katiku. Katiku, are you with us?
Yes.
Yes, Katiku. Maybe let us know from this session what you are able to learn.
For me, the main takeaway was that what John said about skills, that whatever you do, you upscale with skills. That is what will make you relevant in the market after mainly you leave school. And also added on that, and she said that for our employability, our skills have to be on par. So that was my main takeaway. Yeah. Thank you.
Okay, thank you so much. So now I will hand over to Wagatune. Sorry, our colleagues was experiencing a technical hitch, so I had to take over from him. But thank you so much, John Matogo. Thank you so much, Engineer Samuel Ndaro. Thank you so much, Andrew, too. We really appreciate your presence here. We're actually humbled that you took time off your busy schedule to come and inform us, to come and mentor us, to come and address us. It's really a great pleasure. So thank you very much. So now I will hand over to Wagatune Mwaura to continue with the session.
Thank you, Fiona. That was indeed a provocative.
Sorry. Chris has a question.
Okay.
Chris Morimi. Yeah, sorry, I didn't see that.
Hello, thank you for the opportunity. First, I would like to thank John, Sam, and Anne for that wonderful session. I think the most eye-opening for me is what you guys have been able to do in your careers. That was very encouraging for as a student. But for me, I was wondering when I do attend these sessions, what I hear is build up on your skills, because this is what you need. But now that I am doing my attachment, I think I felt like the conversation has changed to skills to experience. Like people here in the say in the companies need people with certain experience. So I was asking, how do this correlate between skills and the experience? Because what we are working on as students, maybe build our classes, maybe trying to develop our name. But when you get out there, what they want someone with, they say 3 years experience working in certain. So how do that maybe go together? Thank you for the time.
Is it okay if I respond to Chris?
Yes, sure, go ahead.
Yeah, so Chris, good point. Indeed, the idea of experience is something that is important and one that I think every employer would be looking out for. Now the thing is here, and let me give you a trick on how to address this issue. One of the things that employers are looking for, and this comes out because of getting, let's say, burnt over and over again. You engage someone as an employee. They say, yes, I have skill in X, Y, Z. When they come in, you realize that there's a deficiency. They have not actually done something practically. And you can imagine from an employer's point of view, that's lost investment, because for them to bring you into the company, that has taken time, and also they are losing in the sense of revenue, because you should have been productive the moment you got into the organization, right? And if that happens a couple of times, you can imagine the frustration from an employer's perspective. So the reason why they put this is to sort of try and mitigate that risk of that kind of situation. But how can you go about this as a student? So what I tell students, when you're undergoing your academic practice, use this as an opportunity to build that experience. Use that as an opportunity to build your portfolio, because what employers are looking for now is more evidence of your capabilities. Let me give an example. If you're a student and you say, I can develop applications in a certain, maybe if it's a web application or it's a mobile application, or I have developed a solution that does X, Y, Z. Oh, that is great. Can you show me? That would actually be more powerful than just telling me that you can do that. So as a student, if you're going through your academic program, I'm sure within the different courses that you're taking, there are projects that you carry out, there are assignments that you do. Use that to be part of the portfolio or the evidence that of capability that you're developing. So one of the things that we do when we work with universities is, for example, we give you access to IBM Cloud. So I put the link in the chat there. Go in there, get an IBM Cloud account. And if you're developing an artificial intelligence solution, maybe you've developed a chatbot, let that be part of your portfolio. So I've developed, for one of my modules in my campus courses, I had to develop, for let's say the artificial intelligence module, I had to develop a chatbot. And I do it very well, because this is not just to pass a certain module or certain course, but it's going to be part of my portfolio. And this, when I go now to employers, I will show them the link to my cloud account, and I can show them, this is application 1 that I developed, this is application 2 for data science or an analytics application, and so on and so forth. So now you're not just telling people I can do this, but you're actually showing them. And because you did that during your the time when you're in university, you developed experience. That's why I say do it very well, because that's going to be part of your portfolio. So you've addressed the capability question, you've addressed the experience, because you're actually showing something you've actually developed, and you're able to address that. So this time that you are in university, use that to build those solutions and let that be part of your experience. I hope that gives you an insight on how you could address that particular point. And not just in IT, but in any other field that you do. Thank you.
Thank you so much for that. Any other question before we head over for the break?
Hello.
Yes.
I would like maybe the speakers to tell us how one can, how they were able to get to the institution they are working currently at, because I think these are high-profile institutions, and we also love to work where they do and what they do. Maybe you can give us a brief on maybe the process.
Okay.
So
We have to excuse.
John, I can take that. So let me ask you, I didn't hear the last part of the question. Can you ask that again, please, Chris?
I was asking, maybe you can tell us how you did get to maybe Boeing, and John can also tell us how now you got, or how one can get to IBM, the process, how you found yourself there, because you are students and you also like to explore in some of those institutions. And also maybe Anne can tell us the process of maybe putting together SwiftLab. Now I've been following SwiftLab on LinkedIn. I've seen you making big strides in Kenya. Maybe you can try to give us a brief on that, how you guys managed to be where you are.
Sure, Chris. So I'll start. I think John touched on some few elements of your question. You have to build yourself as a package. You can't just think of yourself as just a resume. You're not just a resume. What you put on a resume should be you, your package, what you bring to the team, right? And I get it. You graduate, lack of experience, probably an employer is not going to want to hire you and things like that. But the positions out there, for example, at Boeing, that they do hire level 1 engineers who are coming out straight off school, and the understanding is, hey, this person has shown the ability to go through a certain course, so we understand that they have the ability to go through those education plans. And once you get there, it's a chance for Boeing now to put you through their kind of education system to make you a better engineer. So there are certain things that we can do when you come on board, that we can train you and do all these things to get you to be an engineer and work on things that you want to work on. And Boeing is a big company, so we do have stations in Kenya actually and all over Africa. So it's as simple as going to the Boeing careers and then apply for a position. But again, I go back to passion and understanding what you want to do. You have to understand what you want to do. If you don't have the skill set to be in a position, you have to have the passion to want to do that. And once you get into those positions, you have to be able to understand at least at bare minimum what is going on. I don't want you to go apply to be a design engineer and you've not prepared yourself to be a design engineer. You need to take those courses if you have to, tailor your courses in the university towards what you want to do. At least that when you come into an interview, I can tell by your resume, I can tell by your transcripts, hey, this person has done design engineering, this person has done this and this and that. And John talked about certificates. If you have the ability to go do those certificates, do them. It sets you apart from everybody else, right? And I look at the resume, you come in, even if you're not going to practically show me that you can do it, but at least I see that, hey, I can take a chance on this person because of the background that they have, because of the things that they're saying that they've done. And that's why I think John, I keep referencing to you all the time because you have great points. You do not put on your resume something that you did not do. You're going to come in and then you're going to struggle and then you'll not be able to be successful. To get into some of these companies, you only get one opportunity. You don't want to waste that one opportunity. So pick what you want to do. Make sure you tailor your resume towards that. Make sure you tailor your career towards that, and then you get into the company. Lastly, yes, you do that. You get into Boeing. So long as you have the passion, you have the ability to learn, and you want to change within a company like Boeing, you can change within the company. There's different careers within Boeing that you can do, right? But again, that passion, that ability to learn, and the need to want to learn different things has to be there. I can tell you within Boeing, I've done different aspects of engineering up to leadership right now, and half of it I did not learn from school. I had to go through some of the technical trainings within Boeing in order to learn some of those things. So it's great once you get into the company, make yourself useful as much as possible. Thank you.
Okay, just to respond to the question that he had asked, I mean, I will not belabor a point that you can actually find. You can check me on LinkedIn. You'll find my profile is there detailing what I've done. But one thing that I would say got me to where I've been is, trust the process. Be open to start from, let's say, the beginning, from the very basics. One of the things that I always, when I talk to students a lot, obviously my job has me interfacing with students a lot, is that be patient and take time to earn your stripes, right? As much as, yes, having a lot of ambition when you get out of your academic program, everyone wants to be the manager from their first job. There's also value in earning your stripes. If you want to run the restaurant, for example, you also need to know how the toilets are cleaned. I mean, to give an example. So make sure you go through the process, learn from the basics, and go up. I mean, in my career, I started off, as a lab assistant, and I actually say even before that, when I started my interest in computing, it was back at the time when we used to carry the 3.5-inch floppy disks. Some of you might not be familiar with this, but this was my jacket would be stacked up with the diskettes. Because back then, to have an application, you had this small floppy diskette that would only hold 1.44 megabytes. Imagine, you're talking about a memory stick that is way smaller than that is holding 8 gigabytes. Here you're talking about a diskette that has got 1.44 megabytes, and to have an application you need to have 10 of those. So I mean, that's the era that we started off in. So from the time I was working as a lab assistant, maintaining computer systems, learning to connect them, to fix them, etc. Moved on, did some work with an NGO, managing the websites and managing mail systems, etc. Later on, was involved in training activities. Eventually, parallel to that, I was also doing my academic degrees, and then got into teaching as a teaching assistant. Later on, as an instructor, so and so on and so forth. So I was in the university system for some time. Moved on, got involved in innovation, so helped launch an innovation center. Also at the same time, I was doing some work with on training and also in entrepreneurship. Got involved working with universities again on e-readiness projects around the East African scenario. And then, the opportunity came to join IBM because of the work that I was doing. And then again, like from my title, I'm involved in working with academia. And I can tell you, it's always a learning process. So what would be important to maintain that is to have an open mind, be open to learn, be curious to learn, because this is something that's important. You're never at the peak. You've never achieved until you realize how much further you need to still work on to go. So always be open to learn. The other thing I would say is, everybody talks about having good habits, and I think this is something we cannot overemphasize. Avoid the shortcuts. The shortcuts will cost you dearly. So, I think some mentioned, have integrity and take time to just build, learn, build your skills, learn, try the opportunities that come your way. And if it doesn't work out, no problem. Take the learnings from that and then move forward, okay? This is life, so you just need to keep on moving, make sure that you're moving forward and avoid the bad things that all of us know, those things. Make sure you have a good, in this day and age, make sure you have a good digital profile. I see a lot of people that miss future opportunities because of, let's say, wrong decisions, and especially in this age of social media and so on. So, try and manage your online identity, because these things follow you for a long, long time. So avoid those pitfalls that will be along the way, or shortcuts that some people might see and try and get, but actually will completely mess you up. I hope that's helpful. Yeah.
Thank you, John Matogo. That was very helpful. I hope all the questions have been answered. That was quite a provocative discussion, I must say. Now we will, yeah, let's give them a round of virtual applause. Yes, indeed. Asanteni sana. Thank you so much. Right now we will take a short break. Yes, I can see so many people are sending the round of applause. Yes, thank you. Right now we'll take a short break. And then we'll enter into the second session of today.
And every day. As increasing disruption comes with increased productively, but predictively, automating processes to simplify the complex, keeping private data protected, and adapting to ever-changing consumer habits. In a year that was like no other, businesses are taking a scientific approach with IBM to invent, discover, and solve problems like no one else. There's a lot to do, but together, we've got this. Together, we push, prove, demo, dare, work, wow, solve, smart, think. Today and every day, you are doing the impossible in a time that's been completely unpredictable. You're doing it with so little time and under so much pressure. You are juggling and jabbing, mobilizing and modernizing, remote learning and emphasis on the learning.
Sorry, guys. I don't know how to turn this thing off.
You are traveling and transforming, researching and resilienting. Okay, it's not a word, but you know what I mean. You are watching and welcoming, Opening and, oh, wait, now you're closing. And now you're opening again. For businesses around the world, it's a real challenge because increasing disruption comes with increasing complexity and an increasing need to have today's problems solved yesterday. That's why businesses are rethinking everything. Using hybrid cloud and AI with IBM, they're working not just productively, but predictively, automating processes to simplify the complex, keeping private data protected, and adapting to ever-changing consumer habits. In a year that was like no other, businesses are taking a scientific approach with IBM to invent, discover, and solve problems like no one else. There's a lot to do. Together, we've got this. Together, we push, prove, demo, dare, work, wow, solve, smartly. Think.
AI is changing the way the world works, making business faster, smarter, and more secure. At IBM, we're helping companies put AI to work at scale, giving them an unparalleled business advantage. With Watson, businesses are personalizing customer experiences, streamlining processes, minimizing risk, and sparking innovation. With Watson, engineers are keeping millions of elevators moving, predicting when they will break down and proactively fixing them. With Watson, banks are deploying virtual agents trained on thousands of customer inquiries, helping them provide expert service to millions of customers 60% faster. With Watson, a range of industries from healthcare to automotive to telecom to education are working faster and transforming workflows. Businesses everywhere are building their future with Watson. Watson is an artificial intelligence system. Artificial intelligence is what gives machines the power to learn, adapt to new inputs, and make better decisions. Machine learning, a subset of AI, uses computer algorithms to analyze data and make intelligent decisions based on what it's learned. It's how streaming sites recommend new music by comparing what one listener likes to others with similar tastes. Watson uses a sophisticated machine learning technique called deep learning. Deep learning layers algorithms to create an artificial neural network. It can continuously learn on the job, determining whether decisions were correct, constantly improving the quality and accuracy of results. This is what enables it to learn from unstructured data, such as photos, videos, and audio files. Meaning Watson can tell an insurance company exactly how a car has been damaged in a crash by discerning the make and model before comparing images of an undamaged car to the damaged one, even getting as detailed as a broken exhaust. Deep learning is also what enables Watson's natural language understanding capabilities, allowing it to learn by deconstructing sentences, then analyzing and identifying the concepts and relations of those sentences.
Right. All right. We just had a short break after a captivating panel discussion on the topic engineering taking its shape. If you missed it, well, get ready for the next one. Welcome back. Let's get started. Just a reminder, let's keep the conversation going. Type in your comments and questions. Let us be as interactive as possible. Great. The next panel discussion is on the topic Teaching to Learn, Education in the Era of Technological Change. This session will be moderated by Moses Bore. Moses, are you here with us?
Yes, I am here. Thank you very much, Wagatune Maura, for the introduction and for the invitation. And thank you for moderator for the first panel. Yeah, I believe we have been learning and we are still continuing to learn. And we're being challenged in a couple of ways. So I believe this next session shall even be a more challenging one and a more encouraging one for us as we grow. Yeah, it's important for us to see the need of education in this era, even as we are talking about how engineering is shaping how technology is shaping engineering. Yeah, we even are going back to the roots and seeing how education is now shaping or is now working to ensure to shape our technology in this era. So allow me to go direct and invite our panelists. I am seeing that our panelists are joining us from different locations. So I will just allow them to introduce themselves. My name is Moses Bore. I will be chairing the panel. And I will now invite the panelists from, we have Nelly Agemang Gyamfi. Yeah. So she is the County Director, Moringa School, Kenya. She can introduce herself. Yeah.
Yeah, sure. Thank you so much, Moses. I hope people can hear me. Am I coming out clear?
Yes, you are. We can hear you.
Awesome. Great. So as Moses mentioned, my name is Nelly Ajimanjemfi. I'm the country director for Moringa School, Kenya. So Moringa School is a private TVET that teaches technical skills. Currently, we have certificates in data science and software engineering. One of the things that we do like to say is that we like to mimic real work world environment in our classes. So the design of our studies is such that the moment that our students graduate, they are able to add value to the workplace from day one. We're also very heavy on practical skills. So for everything that you learn, there's a practical associated with it that you need to do to show that you've actually imbibed the skills. I'm happy to share that we currently have on average about 89% of our graduates in jobs within 6 to 12 months of graduation. It's a metric that we are quite proud of and we continually strive to improve. A little bit about myself. I've been in education for the past 7 years, working with different demographics and typically sit at the intersection of education and business. So very much an operational person. And I'll turn it back over to you, Moses.
Yeah, thank you very much. Thank you very much for the introduction. We also have on the panel the chairperson for Engineering Students Association, that is for University of Nairobi, that is Isabella Oyo. Isabella, you're welcome. You can introduce yourself briefly and say hi to us. Isabella, you're muted.
Sorry about that. Okay. Thank you so much. My name is Isabella Oyo, fifth year engineering student of civil engineering at the University of Nairobi, at least until September. Also the chairperson of Engineering Students Association. ESA is a body that stands for the 5 engineering departments in the University of Nairobi. That includes biosystem engineering, electrical engineering, geospatial engineering, civil engineering, and mechanical engineering. And our main aim is putting engineering students in the lead. And whatever we are about today in this meeting is about putting the engineering students in the lead. As a person, I play hockey for the University of Nairobi during my free time, and I am into mentorship. I'm also into environmental action, mentorship specifically for the girl child, yeah, and environmental action away from school, out there in the world. Yeah, I'm happy to be here. Thank you so much.
You're very much welcome. You're very much welcome. Also on the panel, we have Michael Kamau, who is a training manager, Huawei ICT Academy, Africa. So Michael Kamau, you can briefly introduce yourself and say hi to us as well.
Thank you very much, the host. Good afternoon, everyone. My name is Michael Kamau. I work at Huawei Technologies Kenya office, and I'm very, very delighted to be here with you excellent students. My background is actually computer science, unfortunately not engineering, but I'm always passionate to be interacting with students because as I will come to maybe talk to you later, the program that I'm currently handling in Huawei Kenya since 2018 is really focused on developing students' capability to join the ICT field. And even for Huawei, I think I'm in the right place because I think 80 or 70% of our engineers are in the engineering field. So I'm very happy to be here and I look forward to engaging with all of you. Thank you so much.
You're very much welcome. You're very much welcome. And last but not certainly least, we have Mentor Ida Nganga, who is part of the panel. She is the CEO for Regional Consortium for Development Africa, that is RCD. So Mentor Ida, you can briefly introduce yourself as well and say hi to us. So, okay, maybe there's a technical hitch, but as the technical team is looking into that, we can go direct into the discussion. I don't know what your expectations are. Yeah, but I believe that you are excited to see how education can be a tool, basically, as Nelson Mandela said, that education is the tool that can be used to change the world. So we will just dive in to the discussion of the day. Welcome so much. Welcome so much. You can just use the comment section to put in your questions there, to engage in the discussion and to be part of the discussion. And let's feel free to engage together in the next around 30 minutes.
Hello, everyone. I'm having
yeah.
a bit of an internet problem. I trust you can hear me.
Yes, we can. Yeah, Ida, we can hear you. Okay. Yeah, I believe yeah, she will resolve the problem as we continue on. And yeah, as we may have seen, the keywords for the discussion basically is just technological change. And we are in that period or that era where things are taking effect and changing really fast. In these years that we are in, the likes of AI and machine learning. And I don't know where we are as a country, Kenya, and I'd like to pose this as a question to the first question to our panelists. Maybe what are your perception of these words, the technological change? Are they foreign to Kenya? Where are we in terms of technology as a country? And where are we headed? So I will pose that to Michael, and also I believe Nelly will be able to come in especially having been to Kenya and seen and experienced maybe. Yeah, Michael.
I thought ladies first.
We can do it different this day.
Yeah. I'm happy. I'm happy to start. Thank you, Michael. Yeah. So education. Where are we now when it comes to education and technology? I think, to be quite honest, when you look at the education field, I think COVID-19 and the pandemic has pushed us to accelerate much faster than we would have anticipated, right? We've seen a lot of schools sort of shift to remote studies, especially when, in mid-March last year, the government shut down physical education. So, for example, in Moringa School, we literally had a week to shift everything online. And I think that even as we sort of, quote unquote, adapted to this sort of new normal that we are living in, we realized that, remote studies and tech-enabled education is here to stay, right? In terms of where we are, I'd say that Moringa School plays in the intermediate to advanced digital skills market. And one of the things that we've been seeing, especially since we moved remote, is that a lot of the students come to us and they don't have like the tools, they don't have a laptop, or we find that for some students, even things as basic as how to set up an email address, some of them do struggle with it. So I do think that there is sort of like room for improvements there in bringing up the whole of the masses to the point where we are able to meaningfully engage as we move into the fourth industrial revolution. Now, that being said, I also do need to give kudos to the government for the positive things that they have done. I think that digitization and digital literacy is something that has been very huge on the government's agenda, and you have seen sort of strides in that direction. So, an example is the Ajira centers, for example, to give people more access to tools and training that will help them become more digitally literate. There's a lot of like conversations with public-private partnerships to enable this. And my hope is that we will begin to see fruits of that labor as we move on. But then I think that for me, the question that I have hanging in my head is, will we recognize the fruits fast enough such that we are not left behind as the fourth industrial revolution moves out? So I'd say that's my general overview of the states that we are in. And back to you, Michael.
Okay, thank you so much. And I think to Moses, the earlier question about where we are in education. I think I will just first mention a little bit of Huawei background. Huawei is a technology company, a global technology company. We are operating in 170 regions. Probably this should have been in the introduction, but since 2015, coming now to education, Huawei is investing a lot into helping institutions of higher learning access the latest ICT and digital skills. So this is done primarily through our Huawei ICT Academy program. And globally, I think I will just speak for Kenya. We have authorized 42 universities and colleges to become our Huawei ICT Academy. And I remember very clearly since in 2020, when we had the onset of the pandemic, I think learning was very normal. We were having all these classes being taken in from university classes, the halls, the institutions. But immediately COVID came, then we were forced to adapt. And I think at the university level, the adoption was quite good. And I know that, for example, I know University of Nairobi was able to have some online classes. Huawei, we were able also to play a role, and we were able to provide a data bundle to students who want to pursue our Huawei certification curriculum. But also I want to point out that it still lies that also majority of youth or students in Kenya are still at the TVET levels or at the lower level institutions. And I know these ones were deeply affected by such. So education at these levels was I believe was quite affected. But I think for the other institutions of higher learning, such as universities and a few of the national level colleges or such, they were able to continue with learning. However, I think technology is very, very, very important in education. And we definitely need, even as a country, to find newer ways to enhance education learning. For Huawei, we are able to provide our partners with meeting platforms. I know probably they have to spend money to get licenses or access to this. So we are very focused on access. And also Huawei is a carrier provider. So we are working with telecommunication companies to provide equipment, 4G, 5G. So another way we can look at this is that we are able to provide the equipment, the latest equipment in the country. We know that in Kenya, the 5G network was launched. I don't know if you're able to access it by now, but we believe that through this trend and heavy investment in technology, in the connectivity technology, such as the 4G network or the 5G network, Huawei can play its role, maybe a little bit indirectly, because I know these technologies will also play a role in advancing education in the future. So Huawei, we really focus on providing the technology to help facilitate education. I think that's it for now, Moses. Thank you.
Yeah, thank you very much. Thank you very much. Good to note that we are somewhere on the map, and believe we are heading there to be among the top. Yeah, the top lot as far as education is concerned and technology is concerned. I don't know if Aida has joined us or is able to hear us. Okay. Sawa sawa. Sawa sawa means still okay in Kenya. I don't know if so we can still move forward. And when we were beginning the session, we had a keynote address by very own Professor Christopher Maina on pre-college exposure to engineering for high school students using robots. And it's much related to education and where we are headed also. I don't know what's our take concerning this now that it's still taking root in our country. Most high school students are not exposed to technical things at that level, but we have seen the change that is coming in. So I want maybe to pose this to Isabella Oyo, having now been to fifth year and passed through that category. What's your take concerning exposing students, high school students to the engineering?
Thank you so much. Okay, I'm going to answer this question from the perspective of a student leader who has not only seen the challenges that students from different walks of life, different backgrounds have gone through to adapt in the university when they get to the university and they need to adapt to this particular way of learning. Now, it is inevitable that we are not going back to where we were after COVID. I know COVID has pushed us to the wall, and as a university as well, have been able to adopt the virtual kind of learning and later on the hybrid kind of learning. I come from a very small village and I went to a very remote primary school, but I went to a very good high school which had computers and which exposed us to maybe the basic knowledge. But at the same time, I've come to university and I have met people who came to know how to use a laptop in the university. I know sometimes it can look, it may not look real to people who have had access to these things, maybe throughout their study lives, but there are people who actually come to the university and learn these things in the university. Therefore, it was such a problem during the time when the university now imposed full online learning for everyone. It was hard for the students, it was hard for the professors, the old professors, to adapt. You would find that a class would start way late because the professor is still trying to find out where the audio is. A student somewhere who was sent home during COVID is trying to get to a place where there is network. So I feel like most of the problems we face as a country need to be solved from the grassroots level. And even this problem, okay, it's not a problem, it's growth, but it's imbalanced. So in order to achieve this kind of education where people are pre-exposed before they get to the university or before they get to their jobs, we need to find a way to reach out to people at the grassroots level. Yeah, so that is my idea on this. Thank you.
Yeah, thank you. I'm also in the same shoes myself because we weren't exposed early enough to these things. Maybe to also shift or to pose it also to Nelly. Maybe is Moringa School targeting just graduates, or are there other targets, maybe high school students, for instance, in the program?
Yeah, so thank you for the question, Moses. For our core programs, we do have a sort of legal mandate for it to be open to high school graduates. So you need to have done your KCSE. However, we also partnered with UNESCO to come up with a curriculum that is open source. So it's open to anyone, and we open it up to like high school clubs or even younger that can use it. So they can use it to build digital literacy skills. So it's you can think about it as it takes you from, you know, what is a computer, what are the components of a computer, all the way to sort of very basic coding. So you can put together a quick and dirty website. It won't be, you won't look at it and be like, wow, but you'll be able to put some things together and maybe even do a website for your mom's shop or something like that. So we do have that curriculum, which we do share with you know, high school clubs that they can use. But in terms of like actually attending Moringa School, you do need to be a high school graduate to be able to do that.
Oh, wow. Thank you very much. Thank you very much for that. Elaborate enough. There's an article recently that I shared in, or I saw somewhere. Adria Moron Salmeron was saying that advances in AI basically has the potential to alter how the world, or to alter the world of work. Therefore, professions requiring emotional and creative intelligence will come to the fore. Maybe, do you agree with Adria in this take? Or in your opinion, is our current education system really preparing students for these redirections in terms of the AI? Maybe to pose this now to Michael. Yeah.
Okay, thank you, Moses. And it's a very meaty question, because you know, when you talk about preparing students, then which students are these? Are they at the primary school level, at the high school level, at the university level? And I think to begin by addressing the maybe younger students, maybe at the primary school level, I know the government, the Ministry of Education, has planned and is rolling out the competency-based curriculum, the CBT, or such, how it's known. And I think there is some progress, but we cannot ignore, or we should not rather ignore the role. We cannot let this be a responsibility only of the government. We have to involve as many partners, far even from private institutes or organizations such as UNESCO, Moringa, maybe even Huawei, to also play its role in developing students. And I think one way we are doing this, even as Huawei, but for us it's at the university level, and also with some programs such as our DigiTrack. So our DigiTrack is one of the flagship programs that Huawei has globally. We've actually partnered with UNESCO in this. So we do try and reach areas where education is not very much prevalent. We have a track with internet, with computers. We are able to go around counties in Kenya and do this. But I think the role of private institutions should not be ignored. And Huawei, one of the ways we are doing this, we launched a certification program. We call it the Huawei Certified ICT Associate specifically in artificial intelligence. So this one is at an associate level, a professional level, and even an expert level. So currently we have made this available to university students, but I think overall we can improve on this and involve more private institutions, more private organizations to contribute, because the advancements are actually with the private institutions. If we had Huawei or if you had Microsoft, IBM, I know they are part of this talk, all play a role, then maybe we could move faster. And then we do accessibility. So which students are students actually able to access? Then comes in the aspect of infrastructure. But currently, I think we are on the right path. From the government, they are launching the curriculum, the competency-based curriculum. But I know this one doesn't touch ICT too much, but I think we are on the right track.
Yeah. Oh, wow. Thank you very much. Seeing we are on the right track, and we have seen recently maybe a shift of education, maybe basing from COVID and also the technological development to now online learning. Is it really posing a danger to our current mode of education or model of education? Or is online learning and physical kind of learning, are they independent, or are they dependent? Maybe what is your take on the blending of the two? Nelly, you can help us in that.
Yeah. So I don't know. I think for me, it gives you the best of both worlds. So maybe to share a bit, even pre-pandemic, Moringa School used to use a blended learning approach, where we had our curriculum hosted online, and students would sort of go through the content in a self-paced way, but with facilitators in the classroom that we call technical mentors. So in that way, you had sort of like the best of both worlds, the ability to quickly update curriculum based on curation of online sources, but having the benefit of, somebody to hold you accountable, somebody to answer your questions, that sort of thing. I honestly think that, online learning, I think it enhances the current educational model. I wouldn't necessarily see them as, as loggerheads or something that causes an obstacle of sorts. Because even if we were to go back to the brick and mortar model, like let's assume that we all move back into schools physically, right? You could see how you could rethink the role of the teacher by utilizing online resources and online learning within the classroom, even in the brick and mortar model, right? Because a lot of the things, that lecturers teach, they teach the same thing year over year over year, right? Why can't we automate this so that the lecturer's focus is more on individual students, right? On blocking them, answering their questions, doing one-on-one, creating, group projects or guided projects that can help enhance a student's understanding, right? So for me, it's a plus, right? There are very little minuses in merging the two.
Sure. Thank you for that. And now I believe Isabella has experienced this kind of learning firsthand, the blended type, and that is after the outbreak of COVID-19 in the country. Maybe, Isabella, do you think this system now, as it is, should it be fully adapted, or are there shortcomings? What can you suggest for its improvement, maybe?
Okay. Thank you. I feel like, okay, online learning was a lifesaver for us. Otherwise, I would still be in fourth year. And at the same time, I feel like there are things that cannot be done online at the end of the day. And I like to tell people we've had this argument with over and over again that human interaction is inevitable. Not even the over the phone kind, because it lacks personal touch. But I want to say that online learning, when incorporated with face-to-face learning, it becomes something very strong. That is, at the end of the day, the online learning makes up for the disadvantages of face-to-face learning. For example, the transmission of of COVID-19 as it is right now, online learning makes it's easier for us to still learn even when we can't meet physically. But at the end of the day as well, face-to-face learning makes up for what online learning cannot achieve. So if we merge these two and come up with a system that is well embedded, what is done online is done, and what is needed to be face-to-face is face-to-face. I wouldn't say that we could go online, totally online, because first of all, Kenya is not ready for it. Second of all, it has the disadvantages of, raising socially awkward people who can only communicate through phones, but when they meet face to face, there's nothing. There's interpersonal skills that are needed at the end of the day. And I feel like if we go online, kabisa, there is always going to be that lack. There's always going to be that lacking. It should be part and parcel of the day-to-day learning, and it should be incorporated in the system. But it should be done in such a way that not only during emergencies do we run to online learning. It should be something that is day to day and something that all students are used to and all students can work with. We did our exams online and most of our scripts got lost. Some people are having missing marks because the lecturers are unable to retrieve their answer sheets. Some were unable to submit. You do the exam, but you think you submitted and you did not submit. So these are some of the things that need to be polished, and these two systems of learning should be incorporated in such a way that they are more, they come, a hybrid should come out stronger. That is why people come together, people collaborate. That's why there are coalitions. It should be able to come out stronger, but only if it is well incorporated in the system. Yeah. So I think for the university, for the Kenyan universities and everything, we appreciate for the universities that were already there in that online platform by the time COVID was coming, they had it easy for people like Strathmore. But for the University of Nairobi, it was a struggle. If we make this part and parcel of learning, say that I can get first year, when you get first year, it's something that you start learning first year and you go on with it. Surprise. Yeah. Thank you.
Yeah. Oh, wow. Thank you very much. I'm seeing the shift that is taking place, and more even advocating for a hybrid, which is quite good. I, I'll now shift to still back to Michael. Huawei being the largest, among the largest, one of the largest technological companies globally. Through the training, maybe in the academy, how is Huawei tailoring its program, and how is it equipping the students to be prepared for the advent, of the fourth industrial revolution that we are now talking about, as Melly had shared even at first. Maybe over to you, Michael.
Okay, thank you, Moses. And I think this is now an important part, because I think even most of the participants in this session may be at university level. And one, as I said earlier, Huawei has launched this ICT Academy program to be a more socially responsible organization by transferring our latest ICT skills. So what we did, as what the organization has done currently, we have developed a very clear we have developed a very clear certification portfolio that is in different directions. So our belief and our goal is to be able to support university students, learn about the ICT industry while at the university. Because us as an organization, as a tech giant, when we take in engineers, when we take in people to work for us, maybe the technology that if they need to be able to work, maybe our equipment or such, it becomes very difficult. Or our technologies are rapidly developing, they are rapidly changing. So Huawei, we have packaged the certification in different directions, and it is at an associate level, professional level, and even an expert level. So what this certification offers is the resources for students to be able to learn directly about the technologies that are in the ICT industry. So we take, for example, our routing and switching or datacom certification. So these ones can be pursued for students who are who want to pursue a career in networking or in a network infrastructure setup or maintenance. It will lay a solid foundation for the students, and they will easily join the ICT industry, and it will prove that they have the knowledge and skills to easily work at Huawei or at our partners or even the ICT industry in general. So the certification is very varied. We have it in ICT infrastructure, such as security, datacom, and we also have it in storage. We also have it in wireless networks. So this one is made available to all our university partners through our partnership program we call it ICT Academy. We also have newer technologies such as cloud computing, cloud service, AI, big data, and IoT. So this is what we call an industry certificate. So this is one of the main roles that Huawei is equipping students for the fourth industrial revolution. And we believe that a student who is able to achieve such a level of the certification, either at an associate level, then they are authorized. Huawei, they can easily show their employer that, hey, I have these skills. I'm able to work with such kind of equipment. If it's, for example, our data center certification, then it will be easier for them even when they join an organization and need to work with a data center. They don't need to be trained by the organization itself. They have already had this training at the university level. So we are very keen on this, and this is basically our whole agenda for our ICT Academy program. That's why the program was launched, to play our role actively in preparing students at university level, at college level, to join the ICT industry with ease, because we know that, for example, I was reading this World Bank report that in Kenya, almost 50% of the jobs will require digital skills. This is just one small example, but we believe these are very key, these are very important, and we are happy to play our role in this. So I think to sum it, I would say that our certification portfolio and other programs that we have are what are the role that Huawei is playing to equip this to all our students, all our student partners, such to join the fourth industry, to be part of the fourth industrial revolution.
Yeah, thank you. I'm seeing that we are moving there. Yeah, I hope we are listening to and we are hearing the opportunities that are available out there. As we are even nearing to the close of our discussion, I will pose also this one to Nelly, as you will also be giving us your final remarks and of the same. One of the popular course offering that is being offered at Moringa School, as per the student reviews, is machine learning. You could briefly expound on what machine learning entails and how can it be applied now in the education, or how will it improve on our current model and system of education? Yeah, as we are closing.
Yeah, so actually the machine learning module is under our data science module. So it's part of the data science courses, and I think one of the things that we all know is that we're moving into a world where data is huge. Big data is a huge thing, and big data is what fuels a lot of the things like AI, machine learning, that sort of thing. And so the ability to sort of manipulate the data, to be able to tell the machines what to do, that sort of thing, it's going to be quite a key skill as we move into the fourth industrial revolution. I think that, as you mentioned, a lot of the sort of like repetitive skills are things that are going to be taken up by machines, but you need to teach the machines what to do, right? And so there's essentially someone behind that, and a lot of that is fueled by data, right? Everything is data, right? If you think about it, the way people react to certain things is what makes, for example, when you think about the call centers and how sometimes their automated responses sound so human, right? It's because of like collating data from the way humans react to be able to build a machine that's able to emulate that. So I think that's a little bit of what I'd have to say about machine learning and how it connects to how Moringa School thinks about it and what we are teaching. Correct me if I'm wrong, I'm also supposed to be giving my final remarks, right? Yes, okay. Okay, so in terms of my final remarks, I think that, the world of education is changing. I think that even even post-COVID, praying that we have a post-COVID, even post-COVID, I think that a lot of the innovations that we've seen are here to stay. And I think that, it's key, I think, to Isabella's points, that we begin to build up the digital skills of students to be able to take advantage of that. Otherwise, we end up in a space where we have a lot of people that are left behind, and where there are gross inequalities that are exacerbated by the kind of inequality in digital skills. So my hope is that players such as the government, players such as the telcos who offer discounted internet, players like Moringa School, Huawei, and even players such as yourselves, because even as students, you do have that agency, because as engineering students, you probably have more advanced digital skills than even the lay person. So the question is, what can you do with what you have, right? Can you go back to your high school and start a coding club and sponsor a coding club, or mentor a coding club, or mentor a digital club? Because at the end of the day, again, to Isabella's point, it's a grassroots effort, right? We can't leave it to any one person. So within your sphere of influence, what can you do to bring us all the way forward? And even if it's just like teaching 5 kids how to use the internet, that's valuable. So I think that's where I will end. Back to you, Moses.
Yes, thank you very much. Very many important things to note there. I also like to give it to Isabella, then Michael, now that we said ladies first, to give their parting shot as well, for a minute or so. Thank you.
Thank you, Moses. I want to put out there that it has been very challenging for students to adopt online learning, but the good news is they have adopted. They have gone out of their comfort zones to get equipped with smartphones and laptops and looking for Wi-Fi everywhere, because actually the University of Nairobi has Wi-Fi, but in specific places within the school. Areas of improvement, even as we journey towards adopting this particular kind of education, because education is an equalizer, and in every institution, every student should be having equal opportunities and being able to access every single resource, so that they're at a competing level. It should not be a case where those who have Wi-Fi will learn, those who don't will sort themselves out. No. So I feel like we should lobby for institutions to be able to support online learning before they adopt it. We should be able to have stable internet and have working computers for the institution, even before we tell students to buy their own laptops and everything. Institutions should be equipped for whatever systems they want to adopt. No. We will excuse this one that we have got because it was we had to react to pandemic. But as we adopt this, we should not just with the few people that are able to move. It should be inclusive. And I like the point that Nani, my fellow, has said from Moringa School. I like what they do at Moringa School, because I have seen students from very remote areas apply for Moringa School and actually get to it. Go back as a person, what is your responsibility in ensuring this equality happens? Because there is no time that will be so ideal that Kenya is now maybe taking care of everybody at the same time. These things start with people like us, people who are not even in the government. What are you doing as a person? I like the point he said, you can go start your coding club. And I feel like as we get out of here, we should think along the lines of how to bring people to the level where they can access these particular resources from primary schools, from high schools, all over the country, so that we should not be growing technologically so rapidly, while one Kenyan somewhere cannot even afford food. They don't even know that AI exists. They don't even know what is AI. they're struggling to know what is their meal next. But another section of Kenya is going to the fourth industrialization. Yeah. So what role are we playing as a people, as an individual? Thank you.
Wow. Food for thought there. Thank you, Isabella. I'll now let Michael also give his final remarks.
Thank you, Moses, and thank you to my other panelists, Nettie and Isabella, for the wonderful comments. I think for me, as a parting shot or as a closing remark, as I said earlier, my background is in computer science. So every time I saw engineering students, I thought they were very special because to study engineering, you have to be very, very smart. So I think at university, from my perspective, there's always a lot of time. So let's invest our time wisely. Let's interact with the industry as much as we can. I really like this forum organized by IEEE, the students organization. Such kind of opportunities, such kind of forums, or such kind of events really expose you to what the industry does require. And I would really encourage you to make use of your time wisely, invest it wisely, invest it in learning. If you're able to pursue Huawei certification, Cisco certification, IBM certification, or even Moringa, if you're able to join such, invest in yourself aptly. And I can almost guarantee, I can really assure you that it will pay off. The skills you learn at university will pay off. And as you do that, as you invest in your ability to work in the ICT industry, there are other skills that are needed. For example, the ability to speak precisely, clearly, to articulate your ideas, your thoughts. I really like our host, Moses, is a very smart guy who is able to host this panel very well. So apart from the skills, the technology skills, you should also be able to work well with other people. As I think Isabella has said, we should not be robots. Even as we learn about AI, we should also learn about the soft skills. And maybe this is where the focus was on engaging with other young guys and promoting or motivating and encouraging them to join the ICT field. So please continue invest your time wisely. If you believe in God, and work, join the ICT industry and make your impact, make your role. Don't be afraid to start at the bottom. Most of us have started there. I don't know Nelly's or story or such, but I know that once you join right now, you are I think their final years here in the meeting, you are at the highest in the food chain at university. But once you join the industry, you join maybe as an intern at the lowest food chain here. So you should, the technology skills are very important, but the other skills such as speaking, communication, presentation will also play a role in your overall career development. So have a clear goal for your career, and I wish you all the best as you pursue it. And let's be united. I like the University of Nairobi motto, Unitate et Labora. Let's unite in this work, and we are very happy to support. And as Huawei, I think I can give my public email. If you want to pursue a Huawei certification, I can maybe help you courtesy of the program. But at the end of it all, thank you very much for organizing this session, and I wish you all the students all the best. Thank you, Moses and my team. And also to the lady who texted me. I think her name is Nyokabi Waweru. Thank you so much for the good work and the organizing of this forum.
Yeah, thank you very much. Thank you very much for that wonderful discussion. Thank you, Isabella. Thank you, Michael. Thank you, Nelly. At least now we know how to handle the timing that we are in, and yeah, it's the ball is in our court as students and youth coming in to go and use the opportunities available to bring a change in the ICT world. So because of time, we will not take questions, but we can get in touch through the LinkedIn accounts that will be shared, the emails that will be shared, the chat. So let's keep watch and let's keep in continuing because there are more programs lined up for us. I will now hand it over to our moderator or our MC, Wagatune. Yeah. Thank you for being attentive.
Thank you. Thank you so much, panelists, for giving us an insightful panel discussion. Thank you so much, Bore, for moderating this panel discussion too. A warm round of virtual applause to them. Okay, great. In the interest of time, if you have any questions, leave them in the chat box and we will follow up and get back to you. Okay, let's get into the next session. I will now introduce our second keynote speaker of the day. He is the IEEE 802.3 Task Force Chair, a distinguished engineer, IP standards, future way technologies. He is an Ethernet evangelist.